recall that last year we had the maiden session of this kind in line with the country's identified requirements of training future leaders of maritime Indias in matters of IMO. This year, as usual, the competition is being held for two critical topics, one in MEPC and second on MSc. The subject of the MEPC session, which is today, is GHG reduction strategy, greenhouse gases reduction strategy, alternate fuels. And for the MSc session, which is tomorrow, is safety and training aspects associated with various fuels being proposed. A core committee of 4 has organized this competition under the aegis of the Indian Maritime University. Mr. Rajiv Nayyar, who is the subject matter expert, a graduate of DMET 83-87. Rajiv is the person who conceptualized this event from scratch last year and continued this year too. After 26 years in shipping in various capacities afloat and ashore, Mr. Nayyar moved to the oil industry where he was CEO of SR Oilfield Services Limited. Since his separation from SR in November 2020, Rajiv has been a maritime consultant and is in extremely great demand. He has been a part of numerous Indian delegations to the IMO and is actively involved with the STCW code as part of the team which works on various aspects of the HTW subcommittee of IMO. Rajiv, thank you very much for conceptualizing this program. It is indeed a remarkable effort on your part. Mr. Doshi, Mr. Rajesh Doshi represents the Mumbai branch of the Institute of Marine Engineers who are supporting this event. A DMET graduate of 1975, he is currently promoter director of Dwarka Kutch Ferries and Tourism Private Limited, which has successfully proven the concept of operating a modern passenger ferry between Okha, which is near Dwarka, and Mandvi in Kutch, across the Gulf of Kutch. Mr. Doshi is an avid mariner and is always willing to share his experience and vision for the future of inland waterways, coastal shipping, as well as education and training. Thank you, Mr. Doshi, for your valuable support in this event. Dr. H.L. Yogmala. Dr. H.L. Yogmala is the go-to person for this event, an associate professor of law at the Kochi campus of the IMU with expertise in international maritime law, IMO conventions, hazardous waste, and commercial arbitration. She has to her credit 10 peer-reviewed research papers and is a much sought-after resource person. Thank you, Dr. Yogmala, for all that you have done for this event. I am Gaurav Agarwal, your host for today, and I represent the DMET Mary Ex-Cadets Association, a graduate of DMET in 1985. I am active in alumni affairs and firmly believe in giving back to the alma mater. So as you can see, it is a unique blend of academia, alumni, industry, and professional bodies who have organized this event. And to top it, we have a panel of 4 extremely eminent judges who are assessing the out-of-box thinking of the youth of of Maritime India. We have Mr. M.V. Ramamurthy. Mr. M.V. Ramamurthy retired from Reliance Industries as President Shipping. He says he's only retired from Reliance. He is not retired from active life. He's still extremely busy. A graduate in mechanical engineering, postgraduate in shipbuilding and naval architecture. He's a past president of the Institute of Marine Engineers, India. His experience includes 10 years as seagoing marine engineer, 8 years in shipbuilding, 35 years in operations of shipping, liquid bulk handling terminals, associate development, and new building projects. Mr. Ramamurthy has been an Indian delegate to IMO MEPC meetings for several years, being a part of its working and correspondence groups. Thank you, sir, for agreeing to be a judge in this event.
Thank you.
Dr. B.K. Saxena, founder principal of Tolani Maritime Institute. He headed the institute till 2018. Amongst his other passions are maritime law, chartering, shipbroking, arbitration. I believe last year he continued studying till last year when he completed a course in international law, I believe. He has represented India at the IMO and has been part of various IMO panels. Dr. Saxena remains even busier after retirement than before. Thank you, sir, for agreeing to be a judge on this event, sir. Mr. Dilip Mehrotra, a mariner of repute. Mr. Mehrotra is a former Deputy Chief Surveyor to the Government of India and Secretary of Indian Ocean MOU. He is a former President of the Institute of Marine Engineers India, 2015-2017. Thank you, Mr. Mehrotra, for joining us on this event.
Thank you.
Mr. Achintya B. Datta, a marine engineer from DMAT 8387. He joined SCI as 5th engineer and continued his fleet service in the SCI till 2002, around 15 years, at various ranks, including chief engineer. After 2 years ashore in SCI, he joined the DG Shipping in 2004 and continued there till 2019 as DDG Tech. He is presently holding the responsibility of the secretary with the Indian Ocean MOU, IMO Secretariat. He has represented India either as a member or as the head of the Indian delegations on various sessions or meetings. Thank you, Mr. Datta, for joining us on this event as judge. Our chief guest for the day, Mr. Sanjeev Vakil. Welcome, sir. Mr. Vakil graduated in mechanical engineering from the University of Madras in 1990 and completed his GME course at Garden Reach Shipbuilders and Engineers and started his merchant navy career in 1991. He swiftly rose to the rank of chief engineer, completing his sea time with various Indian and foreign shipping companies, which include SR, Cisco, Great Eastern, Eurasia, and Sanmar. Mr. Vakil is the founder and CEO of the Hindustan Institute of Maritime Training, an extremely well-known MTI of India. HIMT grew from an institute conducting 3 courses to India's largest maritime institute in terms of number of courses approved by the DG Shipping and continues to maintain this record. As on date, HIMT group of institutes is spread over 5 campuses conducting post-sea courses and pre-sea courses in Chennai and Vizag. He is the first marine engineer in the world to be conferred with a fellowship by the prestigious Nautical Institute UK and is a recipient of more than 25 international and national awards. Mr. Vakil is currently chairman of the Institute of Marine Engineers India and an active member of various committees of the DG Shipping in revising STCW 2010 and is still framing various other course guidelines. Welcome, Mr. Vakil, to this event. He is currently pursuing his PhD at the Indian Maritime University. Thank you, Mr. Vakil, for agreeing to be the chief guest of this IMO mock session competition. And now may I request you to deliver the inaugural address. Mr. Vakil.
Thank you, Mr. Gaurav. Honorable Vice Chancellor, Dr. Malini Shankar, members of IMU, IMEI, judges, guides, industry stalwarts. I know almost each of you on the screen here who are here. Cannot name each of them, but then all my gurus as well who are here, faculty and dear students. Rather, I would say, as last time Mr. Rajiv and I told, not students, it's delegates. So I would say that welcome to you, each of you. A happy morning to each of you. It's been my privilege that to be invited for this inaugural session of the 2nd edition of the IMO mock session, which is certainly an innovative idea. I was just seeing the invite where it was mentioned that it is to inculcate the cognitive skills among the future leaders of maritime industry, besides adding the knowledge in regulatory matters. But I would say that why only future leaders? I would say including the present leaders or present faculty and seafarers, because very few of them, okay, we all sitting ashore, okay, very few of them have this opportunity to go across to IMO or be a part of it. But otherwise, I would say that most of them are still, I think, at the nascent stage. They are not aware of what happens at IMO and how the working is across. And I'm sure that this opportunity which this young cadets are getting across is tremendous, and it's been an innovative idea. I did hear wherein I think last year's speech where Dr. Mani Shankar was mentioning that in December 2020, she went for some alumni meet at Kolkata or somewhere, and then that's the time she had this particular idea. That was the time when this idea came in, and it was just in 4-5 months I could see that the whole thing came across. And I would say that the stalwarts of the industry who have been here across, and also the mentors who are there, I think they are with their knowledge. I'm sure that I think this particular sessions would be a great success. I've also been given to understand that this particular year, out of the competition, there are 18 out of 31 teams from 11 campuses for MSc on the safety and training aspects associated with various fuels being proposed. And similarly, we have 12 out of 28 teams from 13 campuses for the MEPC greenhouse gas reduction strategy of alternative fuels. Certainly, I appreciate the efforts taken by the organizing team to simulate a similar scenario like IMO, wherein the delegation of various countries, basically right from the developed countries, developing countries, English-speaking countries, and where not, everybody come to the IMO, and here we have the same array of inter-college and intra-college competition between the students who are from different parts of this country. Certainly, I would say that last year the topic was on STCW, that's STW, and the MAPOL on plastic pollution, and it was a great success. But last time there were only 6, I was told 6 particular colleges of IME alone. And thanks for including the affiliated college as well this year, wherein the numbers have probably affiliated colleges also gone into it, and they're also getting this exposure this particular year. The topic is certainly hot, and it's relevant to the industry today because this topic, wherever you go today, it's on alternative fuels. And even last week we had Shri Ajit Sukumaran and IMEI jointly, when the topic, as per the World Maritime Day theme itself, was on this topic. And it's really very relevant that the young cadets are getting into it. And today, these alternative fuels, which we are speaking across, it's going to change the whole scenario of a marine engineer, right from what fuels we used to call as heavy oil, diesel oil, gas oil, everything is now going to methanol, ethanol, hydrogen, ammonia, whatnot. And India, I think, is taking a great lead. I know in this particular part of it, from the training aspect, I would say that India has taken a great lead. I remember the course on IGF. These were the courses which were not heard of till about 2 years back, when DG Shipping was one of the first to introduce globally the guidelines of this particular course. And today it's, I think, including HIMT, there are 4-5 institutes conducting this course. Whereas I would say the same thing in UK scenario, we see only one institute conducting this particular course on IGF. So certainly India has moved quite ahead in this particular course, and number of seafarers, I would say number of seafarers from India taking over such vessels. Various shipping companies, about at least 10 to 12 shipping companies have already gone ahead, and I've been told in the order book there are about 250 vessels right now which are going to be having these fuels. So I know that day is going to be long, the 2 days, today and tomorrow, and there's a lot of things which are going to come out by the students, and we like to hear to them. With this, probably I would like to not be in between the way of the students who are eagerly waiting to have this competition started, and I wish them good luck. I once again thank the organizers for inviting me, and certainly look forward for a very educative session for today and tomorrow and the following next week. Thank you, and Jai Hind. Thank you.
Thank you, sir. Thank you so much for your inaugural address and bringing out the various aspects of this event. Now, without much ado, I call upon Mr. Rajiv Nayyar, the person who conceptualized this event from scratch, to explain the competition methodology and take the program forward. Mr. Rajiv Nayyar.
Thank you, Gaurav. Good morning, Mr. Vakil, Chief Guest for the occasion. Good morning, judges. Good morning, all the guides who have helped the students along. Good morning to the coordinators of the zones, the campuses. Good morning, delegates. And of course, good morning, my core committee members. Welcome. I would start, what I want to address is the delegates. Basically, I just want to tell you what we are looking for in the forthcoming few hours that you'll be attending this session and participating in it. At IMO, you have about, at any given point of time, more than 100 at least out of the 150, 160 member states who will be deciding what sort of international regulations go about. Obviously, every member state wants to ensure that the international regulations are in the best interest of their national interests as well. So you get an opportunity to present your views through papers. At IMO, how you are able to impress the balance 150 odd people will largely depend on how you are able to introduce your paper. And of course, how your paper is written. Because everybody would have read your paper and come to the session, which is what first thing we expect when you are attending, let's say in a session of 4 or 5 teams, each one of you has read what the other one has written. That is what causes the interactions there. And if your paper is written in a method which gives the comfort to the other member states that yes, this is something which can be taken forward, you move ahead. Else, the people who are able to do that, those voices become what becomes the international regulations. So finally, it is trying to inculcate this sort of a culture where you are able to present your ideas across is what we desire, as well as gain the knowledge as how it could be influencing, because it's very easy later on to say we are over-regulated, etc., etc. But finally, these regulations are brought in about by a cumulative effort of all the member states. Here we do a bit of a differentiation, considering that we are still dealing with a large number of students. We do allow you, rather than just give a presentation, we allow you to do a presentation rather than introduce your paper, because we understand that there could be a bit of limitation in that. Though as we go along, that is something hopefully in the final rounds we are able to inculcate more. So look forward to your presentations. You're being able to present in a way that you're able to give comfort to your other members of your group that yes, what is suggested by this team is what is relevant. And of course, those presentations should be in a format which is aligned to what your paper has talked, so that they can correlate. Please do also appreciate one aspect of IMO, which I'll explain to you. There are members who have different national languages. About 6 languages are recognized by IMO, and these do provide translation services. So what you are going to speak is going to get translated, if you are in an actual IMO plenary session, into 6 other languages. Therefore, speaking in correct English, considering that all of us are English speaking in this forum, easily understandable English for the translators to be able to translate into other languages, speaking at a speed which is understandable by other delegates is also critical. Please do keep this in mind when you present your presentation, and after that, respond to the interventions. When a presentation is made, we'll be giving 8 minutes uninterrupted, where no interruptions will be allowed, except as a chair, I have always the right to intervene if there's a problem. And the judges also have the right to ask a question at any point of time if they feel something is required for them to be clarified. Other than that, everybody else is requested to please listen to the uninterrupted presentation for 8 minutes. After 8 minutes, the floor will be open to the balance teams of the same group to be able to intervene. You are requested to use your raise hand symbol, and according to the serial wise in which your hand is raised, you will be allowed to intervene and give your comment. Please make sure it is concise, relevant to the paper under discussion. and finally, the presenter would be given an opportunity to respond to the interventions. Thereafter, we'll be taking a short break where, as chair of the session, I will be consolidating my thoughts and presenting a summary at the end of that break. So this is in a nutshell what are the sort of instructions which have also been circulated to you in written format. So look forward to interesting sessions going ahead, and back to you, Gaurav, to introduce the first session. Thank you, Gaurav.
Thank you, Rajiv. Thank you so much for explaining the methodology to the delegates. And moving to today's session, today is the MEPC session, Greenhouse Gases Reduction Strategy, Alternative Fuels. 28 teams from 6 IMO campuses and 7 affiliate institutes have been reduced to 18 teams today, who will battle it out in the semi-finals to reach the finals. We will start with Group 1. Group 1 consists of the C1 team from Chennai zone, the A3 team from Mumbai 1 zone, the D2 team from Mumbai 1 zone, and the E2 team from Mumbai 1 zone. The guides, the Mumbai 1 zone guide for MEPC is Mr. Mohan Pal Singh. Mr. Mohan Pal Singh has stayed for 18 years with various companies and then various roles ashore, including more than 12 years in training. An extra first class engineer, he is presently director MEPC at the Institute of Marine Engineers, India. Welcome, Mr. Mohan Pal Singh, and thank you for agreeing to be a mentor and guide for this program. The Chennai zone guide for MEPC is Mr. Mahesh Subramanian, an alumnus of DMED Kolkata 91-95. Mahesh has stayed for 12 years before coming ashore in 2007. He was instrumental in setting up the Anglo-Eastern Maritime Academy, and he was there from 2010 to 2019. He is presently involved with environmental and sustainability related work in the Anglo-Eastern Group. He is active in IMO activities and a regular MEPC meeting. Mahesh is also contributing on aspects related to ballast water. Thank you, Mahesh, and welcome. I now hand over to Mr. Rajiv Nayyar, who will now conduct the various sessions today. Rajiv, over to you.
Thank you. So I now don the hat of the chairman of the session for Group 1 on MEPC. The session is now commencing. Good morning, delegates, and welcome to this session. I now request Mumbai 1 A3 to kindly take the floor and present their paper. Thank you, Mumbai 1 A1, Mumbai 1 A3.
Good morning, everyone from the panel. I'm from the group A3. My name is Aman Bakshi. So I'll be starting it in a second. So good morning from the panel and the other delegates. My topic for today, the proposal that we are bringing forward is to reduce the GHG emissions at sea by utilizing waste heat energy and consequently the reduction in tank to wake emission factors in the use of fossil fuels. It is in our group, the leader is Akash Malviya and the other members are Nikhil Chauhan, Akshay Rana and Aman Bakshi, myself. So our idea is to use a vapor absorption refrigeration system instead of the vapor compression refrigerant system on board the ships for air cooling. We'll be doing this by utilizing the waste of the heat energy generated by the internal combustion engine in the exhaust system, that is from the main engine, and the results in the significant fuel savings and pollution reduction. That is the main concern. The issues with the current vapor compression refrigeration system, the emissions are there, the upfront and maintenance expense is high, the costly refrigerant is necessary, and the main issue with the vapor compression system is it is preventing the refrigerant leaks, more noise and wear and tear because of the moving parts, and the refrigerants used VCR is responsible for ozone layer depletion and high potential for global warming. In the vapor absorption system, the compressor that we are using in the vapor compression system, it is replaced by an absorber which dissolves the refrigerant in a suitable liquid. A liquid pump is there to raise the pressure. A generator for heat addition, it dries off the refrigerant vapor from the high pressure liquid, and the refrigerant used in the vapor absorption system is a combination of ammonia and water. This is for the below 0 degrees Celsius purposes. For above 0 degree purposes, we'll be using a combination of lithium bromide and water. So this shows a flow chart for our proposed procedure. Here we can see as we are taking the exhaust gases from the main engine. It after passing through the turbocharger and the exhaust gas boiler, it comes in the generator. Here in the generator, we are actually heating the strong solution of ammonia and water. After that, it goes through a rectifier and analyzer where the water gets condensed and the ammonia vapors move on to the condenser where it is getting condensed by the water system, cooling water system. After that, it is similar to the vapor compression refrigeration system where it goes through a receiver, expansion valve, and then in the evaporator to cool the area that for which it has been prescribed. After that, in the absorber, there is water present inside it. Here, the ammonia vapors which were created in the evaporator after absorbing the heat gets absorbed in the water, and then by increasing its pressure using the pump, it moves on to the generator. Here we can see that there's a heat exchanger in between. This is to increase the efficiency of the system by taking in some heat from the weak solution that is being formed in the rectifier. The condenser, here the refrigerant is heated to ambient levels while the heat from the vapor is removed. Expansion valve, the refrigerant is passed through expansion valve to lower its temperature below that of the room temperature. The evaporator, the refrigerant absorbs the heat from the evaporator. A cool strong solution of ammonia and water is pumped using the small pump from absorber to generator. And in the generator, we heat the strong solution of ammonia and water so that the ammonia vapors with a little moisture forms. Hot wick solution of ammonia and water is circulated back to the absorber. A pressure regulating valve is present there to maintain the pressure difference. A rectifier is there. It is a double pile shell and coil or shell and tube type of vapor cooler. It is usually water cooled. Cooling is just sufficient to remove all the water and leave only ammonia vapors in the condenser. Heat exchanger is used to heat the cold strong solution. So from the analysis, coefficient of performance in the vapor absorption refrigeration system, as we know, it is a ratio of refrigeration output to the compressor power input in case of vapor compression refrigeration system. So the COP is nearly 3 to 4, but in our vapor absorption refrigeration system, the one which we are proposing, it has a COP of 0.5 to 0.7. But the main thing that we need to see here is that we are saving a lot of energy because we are using the waste heat energy in this case. Hence, it is overall advantageous in reducing the carbon footprints. And upon comparison between the compressor used in VCRS system and the pump used in the vapor absorption refrigeration system, the work input to the pump is negligible compared to the compressor. In contrast to the vapor absorption, where the pump uses less power for a flow rate of 3.5 kilograms per minute, a pump of 12 volts, 2 ampere, that is 24 watts, is more than enough for it to increase the pressure of 1 kg of ammonia fluid, which is negligible. Whereas a vapor compression refrigeration system requires a significant amount of power due to the usage of a compressor. The gray areas that we have found while looking through a system that needs to be looked upon are the COP is very less, that is around 0.5 to 0.7. So research needs to be done more to improve the COP. A better refrigerant can be used to cool below 0 degrees Celsius, as we all know that ammonia is toxic as well as flammable. But this is not much of a big factor because since the ships today are carrying ammonia as a cargo also, so if they can handle the cargo, I can surely say that it can be handled as a refrigerant as well. But in the future, to be on the safer side, we should find some other refrigerant to prevent this problem. And as we can see, the lithium bromide water vapor can be used for temperatures above 0 degrees Celsius. The disadvantages of the vapor absorption refrigeration system: this system at the moment cannot work where the main engine is in the stopped condition. The system requires comparatively more space, so some of the cargo space is compromised, and it is a complex system, hence requires a bit more maintenance. Maintenance cost for the system is high. Ammonia, water over the other refrigerants. It has zero GWP and ODP compared to the prevailing refrigerants at the moment used in the vapor compression refrigeration system. Ammonia-based system acquire less space compared to the CFC-based system and 3 to 10% more efficient refrigerants than the CFCs. Cheaper and easily available than the CFCs and the HCFCs. Applications of the system. The system can be used in passenger ships, reefer ships, cargo ships, etc. For example, if we want to use it in the accommodation area, where a minimum temperature of 23 or 24 degrees Celsius is required, we can easily use a lithium bromide and a water solution. Use of vapor absorption refrigeration system to enhance the performance and save the environment from problems like the greenhouse effect and the ozone layer depletion. And to increase the COP of the system, green energy sources like solar energy can be incorporated into the traditional vapor absorption refrigeration system. So we would like to conclude by saying that by using the proposed vapor absorption refrigeration system, the waste heat energy is used as an air cooling system. There is a considerable reduction in GHG emissions. There's a reduction in the fuel consumption, a reduced load on the generator, and there's a use of ammonia water as a refrigerant, which has zero GWP and zero ODP. Thank you, sir.
Thank you, Mumbai 1A3. Thank you for the innovative ideas expressed in your paper. I now open the floor for views from other delegates. E2, Mumbai's Zone 1.
Yes, good morning to all respective dignitaries. So my question to team A3 would be, as you had mentioned, that the space consumed will be more and the cargo space should be compromised. Why would any owner be willing to accept this proposal if it is compromising the cargo space, as the cargo space is something that brings them a huge revenue?
Thank you from the E2 member for bringing forward such a question. So, as you said, that it is taking up a little of the cargo space. But as we can see in the present moment in the industry, there are scrubber towers also. Even they consume up some space, but they are present there to reduce the environmental effects that we are having. So, I guess a bit of space consumed for the betterment of the environment and for reducing GHG emissions won't be a much of an issue for putting up with a system like vapor absorption refrigeration system.
Okay, thank you, A3. I see E2, again you have your hand up. Is it a different question or?
Yes, sir.
Okay, please go ahead, E2.
Respected dignitaries, I have a question to the A3 team. So the question is regarding that we are using the ammonia as the refrigerant in the system. So ammonia is highly toxic. So by using the ammonia in the onboard ship in your system, how this will be achieved, this toxicity, how to reduce this system?
A3, would you like to respond?
Sure, sir. So thank you for the question. So as I had already mentioned, ammonia is being transported as a cargo by the ships in the industry. So if ammonia is used as a refrigerant, I guess we just need to be a bit more careful and have a gas detector systems like we have for our cargos, and we can prevent any incidents from taking place. So I guess we will be confronting that problem in this manner.
Thank you. I see C1 of Chennai. You can raise your question.
I wish all the committee very good morning and all the viewers also good morning. My question is, on board ship we already have certain waste recovery systems like exhaust gas boilers, economizers. So why would we use vapor absorption refrigeration system?
It is to thank you for the question, but the answer to this, I will be saying that there's still a lot of heat lost in the system. So we can still use that heat for better efficiency. And if we see the other factors, like we are bringing up with refrigerants which have zero GDP and a zero, uh, like a zero GDP, so that is a betterment for the environment. Like there will be less leakages, and if there are leakages also, it won't be a much of a factor for the environment purpose. So it has better advantages to it.
Thank you.
Thank
And
you.
finally, I see D2 Mumbai Zone 1 wants to raise an intervention. D2, the floor is yours.
Good morning, one and all present here. Sir, I would like to take your permission before asking the question.
Please go ahead.
Yeah, my question is, this system involves higher initial cost. Like, how would you like to propose any decreasing the cost or something in that? Or how much will be the higher initial cost?
Thank you for your question. So, as we have seen in the past, coming up with any new system, the initial investment is high, but we also have to keep in mind that this is for the betterment of the future, for the environment. So, initial cost will be high, but true, after this system gets approved, the newer ships will be built on a more dominant vapor absorption refrigeration system than on a vapor compression refrigeration system. So that is going to reduce in the future, but at the moment, yes, the investment will be a bit higher.
Thank you.
Sorry, sir, to interrupt, but I want to add one more thing that,
Sorry. Who is on the line, please?
sir, I'm Akash Malviya from the team A3 only.
Please raise your hand if you want to take the floor.
Sorry, sir, but
Yeah, I suppose. Yes, go ahead now.
sir, I want to add one more thing that, but we know that initial cost is high, but the operating cost means we have to use, we are using a small pump only. So that will be, means the running cost will be less. So we can adjust, we can compromise. Uh, uh, means this system is workable.
Okay. I see D2 Mumbai Zone 1, you have again raised your hand. Is it something new you want to ask, or is it for the clarification?
Yes, sir, this is something new.
Okay, go ahead.
Good morning to all the gentlemen present here. I would like to take permission from the everyone to present my question.
Go ahead, please.
Yeah, Team A3, actually, what kind of piping system you are going to use in this system? Because we are using ammonia and it is very intoxic and it can react with the other pipes. So, what kinds of pipe you are going to use?
Actually, we are using wrought iron because it does not react with ammonia.
Okay, and what about the properties and the costing about about the interest in companies?
Yeah, I think if you want to get into those details, maybe in a coffee break or something, you can get together and share information on that. I'm sure the presenters would be able to give you details. And yes, there are issues with certain materials. I'm sure they would be avoiding those materials in their system. So if no further questions for the floor, I would like to move on to the next presentation. I invite Chennai C1 now to introduce and present their paper. Chennai C1, the floor is yours.
Yes, sir. Good morning, all the committee members, and good morning, all the viewers. So, myself, MB Monapa, I'm from HIMT, currently pursuing JME 20.
Myself, Rakesh Gowda KS. I am from HIMT.
And we are representing Team 1, MEPC. We like to give our own part of solution for reduction of greenhouse gas emissions from international shipping. One of the main aim of MEPC is a reduction of greenhouse gas emissions from international shipping. We all know effects of greenhouse gas. For a country like C1 that has good amount of shore, rise in sea level will affect the cities that are near shore. And C1 depends mainly upon fossil fuels and gaseous fuels for the energy. Hence, they produce a lot of greenhouse gases. This will affect them in return, causing acid rain, smog, air pollution. So IMO's initial strategy aims at reducing CO2 emission by about 50% by 2030 compared to 2008. Greenhouse gas emissions from shipping industry. The emissions from international shipping has nearly rose to 5% in 2021. So by looking at this data, we are not well closing in on IMO's goal. So IMO's revised strategy aims at reducing carbon emission by about 40% by 2030 and about 70% by 2050 and completely eliminating greenhouse gas emissions from international shipping by the end of the century. And we are planning to achieve this goal by reducing carbon intensity, improving energy efficiency design index and energy efficiency for existing ship index. Ammonia as an alternate fuel can be used for reducing carbon intensity. Ammonia can be generated by Haber-Bosch process. Here, hydrogen and nitrogen from atmospheric air is combined to form ammonia. In blue ammonia, the CO2 that is formed out of steam reforming of methane can be captured by underground rock formations. So this reduces the impact of carbon onto the planet. Next, we have green ammonia. Here we generate hydrogen by using electrolysis of water. Electrolysis consumes a lot of power, so we are using alternate fuels or alternate or renewable energies to produce power that is used in electrolysis of water. Life cycle assessment of ammonia. The energy that we require is coming from either renewable energy or any other forms of clean energy. It is used for electrolysis of water and synthesis of ammonia. It is stored, transported, and reached wherever it is required. For example, shipping and other industrial uses. Well-to-wake emission for E-ammonia. As you can see in the chart, E-ammonia compared to MGO that we are currently using has almost zero carbon emission. And the NOx that is being emitted by E-ammonia is less than half compared to E-LNG. Energy consumption for E-ammonia. So when we consider well-to-wake, E-ammonia consumes less when compared to all other E-fuels. We need 4.2 kilowatt hours of energy to produce 1 kilowatt hour of propeller power. And E-ammonia is cheapest among other fuels. This will be a very plus point for our shipping industry, since shipping is based on capital. So when shipping transits towards e-fuel, E-ammonia will be the leading fuel since it is cheap. It is easier to shift to E-ammonia because shipping has already enough knowledge on how to handle ammonia and how to carry ammonia. Advantages of ammonia over hydrogen. Ammonia is easy to carry. Ammonia can be liquefied under a pressure of 10 to 15 bar. It can be even liquefied under minus 33 degrees Celsius. Ammonia can be even used as a carrier of hydrogen. We can carry ammonia in liquid form, and ammonia can be cracked to produce hydrogen from it. Infrastructure for E-ammonia. Thuthukudi Green Ammonia Project uses seawater, and by the method of electrolysis, we extract hydrogen, and nitrogen is extracted from atmospheric air. This uses a lot of power. Power is we're getting it from solar panels. India is a similar country like C1, which is developing. But C1 has enough spending on infrastructure. So we can use this technology and develop our own e-ammonia projects. All over the world, we have many successful e-ammonia projects. By this data, we can know that supply chain of ammonia is continuously improving, and the easy availability of fuel will be a major plus point for shipping industry. I'd like to hand over the presentation to Rakesh Gowda.
Now, I would like to briefly speak about ammonia used in engine. In spark ignited engine, we can use pure ammonia and we can achieve no knocking even at a compression ratio of 14:1 at rated RPM. Also, ammonia can be easily converted into gaseous form at 10 bar pressure at 25 degrees Celsius. Total engine power increased as we advance the fuel injection timing with respect to load. By this, we can say e-ammonia is having a better fuel efficiency than any other e-fuel. For injecting liquid ammonia, we can follow the method used in hydrogen injection. Then, to improve EEDI and EEXI, fitting MEPC deck is one of the most efficient methods. Unique features of MEPC deck, it can retrofitted on existing as well as newly designed ship. Main advantage about MEPC deck, it can not only reduce the required power by 8%, also significantly reduce the vibration excitation by reducing the pressure pulse by 80%. By looking into all of these details, I would like to give a conclusion that why we can use e-ammonia instead of other fuel. When compared for other fossil fuels, carbon emission from e-ammonia is nearly zero. This helps shipping to achieve IMO's goal. As there are many successful ammonia projects all around the world, it will be improved supply chain. In e-fuel category, energy required to produce e-ammonia is comparatively less. One of the major advantage of e-ammonia is economically way better than any other e-fuel. As we know, shipping has better experience in handling ammonia. Changing over to ammonia is much easier. Usage of energy saving devices can improve EEDI and EEXI, also reduces fuel consumption. I would like to thank each and everyone for giving this opportunity.
Thank you very much, Chennai C1, and I now open the floor for the intervention from the other participants, other delegates. Please do keep in mind that once you have finished your intervention, please switch off your mic, and if you're required to come in again, please do raise your hand again. And I would request the teams to coordinate so that they consolidate their views, and in interest of time, give a consolidated intervention instead of one by one. Thank you very much. I open the floor for interventions. I call upon D2 Mumbai 1. Please, the floor is yours.
Thank you very much, sir. Sir, I had a very small question from a colleague fellow. How do you plan to control the output of e-ammonia? Because according to my study, the output of ammonia is very less. So how do you plan to tackle that?
Output in the sense, the energy from ammonia.
Yeah, the production.
Okay, C1, would you like to respond at this stage?
Thank you. Thank you for your question. So we'll have to modify engines. Like as we told regarding the engine specification, e-ammonia should be used on certain conditions. So that can improve the efficiency of engine. So there is still research going on, and we are sure we can achieve such feat with ammonia as well. Thank you.
Okay, yes, I am sure people would be interested to know as your research further develops, and you could share that possibly later on once you have some results. Meanwhile, I see E2 Mumbai Zone 1 wants to have an intervention. E2, the floor is yours.
Yes, sir. Thank you. With respect to the chair, I have to ask to the team C1 about the if ammonia. Normally, the industrial ammonia is produced by the normal process. That means CO2 is highly emitted. 1.81% of the CO2 is emitted usually by the production of ammonia itself. So my question is that producing the e-ammonia, what's the rate of production using this e-ammonia production? So normally industrial, they want a large production. So by using these types of productive type, how you will produce for this vast industry, this marine field, for the huge use?
So if I understand correctly, your query is regarding the capacity of the e-ammonia which they're proposing.
Yes, sir.
Okay, would you like to respond to that, C1, at this stage, or do you want me to accumulate the other points?
Yes, sir.
Okay, go ahead.
Thank you, Team E2. Since ammonia is still a developing market, the capacity is yet to increase. But I'm sure we'll have enough capacity to cater for all the shipping industry.
Thank you. Thank you. E2 Mumbai Zone 1, you want to take the floor?
Yes, sir. Thank you. My question to Team C1 would be, as we all know that ammonia is highly flammable and also very toxic. So how would you be tackling this effect of ammonia while using it as a major fuel?
Thank you, E2, for your question. So shipping industry has enough experience in carrying ammonia as cargo. So there are a lot of safety measures that are being already implemented. So our next phase would be training the officers in handling ammonia regarding the safety measures and emergency situation that might come on board when we use ammonia as fuel. So it's only a matter of training so that we can implement ammonia into shipping. Thank you.
Thank you. And I see A3 Mumbai Zone again wants to come back. Is it on something different now, or something which has not been covered so far?
Yes, a different question.
Okay.
So my question to C1 is, so you are using ammonia as a major aspect in the ships, but how will you consider it? Because ammonia is also being used as fertilizer and all. So will it affect the production of ammonia in other aspects?
Thank you, A3. C1, would you like to respond to that?
Thank you. Yes, I would like to respond. So the ships that are using ammonia is still limited. So our only matter is to improve the production facility so that we can cater to shipping industry. It is still a developing process. So yes, it will take time. I'm not saying we can implement it just next year. So it takes time for anything to be implemented. Thank you.
Thank you, C1, and thank you for all those who have spoken so far. Thank you for your active participation in the discussions and taking these views on board. Considering that there are no further hands raised, I will move on to the next delegation. I would call upon Mumbai 1D2 to kindly present their paper. Mumbai 1D2, the floor is yours.
A warm good morning to everyone present here. Respected chief guests, guides, and all the faculty members, and my dear friends. First of all, I would like to thank IMU for giving us this platform to share our views on reduction of greenhouse gas emissions, which is the most awaited topic of the decade. No one wants to have a drastic climatic change or people suffering with respiratory diseases. I'm pretty sure no one wants that. For hence, the reduction of greenhouse gases is extremely urgent. Let's begin our today's discussion with IMO's vision. IMO in his latest guidelines has clearly mentioned about cutting the greenhouse gas emission by 50%. So is my presentation visible?
No, not yet.
Okay, so just a sec. So now is it?
Yes, it's loading. Yeah, go ahead.
Sorry for the inconvenience. So first we'll begin our discussion with discussing about the IMO's latest vision. IMO has clearly stated to cut the greenhouse gas emission by 50% at the end of 2050, comparing with the level of 2008. We have divided our possible measures that can be taken in 3 different measures, beginning with short-term and mid-term strategies. These strategies are simple modifications that can be made in the engine to reduce the fuel consumption and hence increasing the efficiency. Beginning with engine power limitation. Engine power limitation is a very simple process to reduce the RPM of the engine and hence reduction in the fuel consumption by around 1 to 4%. Moving on to propeller boss cap fins. These are simple arrangements that can be added to ship's propeller and hence due to the pressure difference between the top and the bottom platform of the propeller, there is an energy saving of around 3 to 5%. And further research is already going on. Moving on to air lubrication. This is a very latest technology which involves reducing the resistance between the ship's hull and seawater using air bubbles. This can reduce a large amount of fuel by around 10 to 15%. Going ahead to propeller guards and rope cutters. These guards do a very simple job. They just avoid the entanglement of fishnets and ropes around the propeller, thus reducing the fuel consumption by a very minimum 1 to 2%, but yet very efficient. Going ahead, we have this EEXI requirement in the latest. We are proposing this graph and we'll explain how this goes. So this is the phase which is currently we are in, and by involving these retrofits and all, we'll reach this phase 1. But again, our requirement is this phase 2. This is our required EEXI. So yeah, still a lot of work needs to be done in order to achieve our goal. Moving ahead, as we all know, the fuel is the heart of an engine. So we need to find out ways, we need to find out renewable alternative fuels that can be implemented so that the enormous carbon footprints of HFO can be avoided. As we all know, the sulfur levels in ECA regions is now, according to January 1, 2022, it should be less than 0.1%. So we need to think something out of the box. We'll be proposing 3 propulsion methods: electric propulsion, hydrogen propulsion, and most importantly, ammonia propulsion. Electric propulsion is again a very reliable, it has a very great maneuvering power, but again, it comes with several drawbacks. The energy conversion from fuel to propulsion is very less. Large volume is required because of its large components. The efficiency, the most important thing, is very less compared to a conventional traditional system. And again, the installation cost of electric propulsion is very high. Now moving on to hydrogen. Hydrogen is undoubtedly the most abundant gas present in the environment. It is a very clean source, but again, it comes with few demerits. Like it has a very low volumetric energy density, meaning it requires a large storage capacity. It is an invisible, odorless gas. Hence, the leak detection becomes difficult, and that is quite a problem. Hydrogen has a wide flammability range ranging between 4 to 77%, hence making it to be extremely explosive. And the most important thing, it requires a low cryogenic temperature of around minus 253 degrees Celsius, and hence development of cryogenic tanks in ships will be required, which is quite a troublesome work. And hence moving to the most important bit, ammonia, the future of shipping. Ammonia, the energy density of ammonia is much higher compared to hydrogen. The high octane ring of ammonia enables us to promote the anti-knocking property. Again, the transportation of ammonia is easier compared to hydrogen. The narrow flammability range of hydrogen is ammonia is 4 to 15%, and the chances of explosion is nearly negligible. Ammonia can be used as a hydrogen carrier because of 3 atoms of hydrogen present in 1 molecule of ammonia. Compared to hydrogen, ammonia can be stored in liquid form at minus 33 degrees Celsius, and at the same time, it's very cheap. But again, everything comes with few demerits, and we have proposed our possible solutions to that. Beginning with high injection temperature. The ignition temperature of ammonia is around 650 degrees Celsius. Hence, we have proposed the idea of using a pilot fuel which can be used for the first 15%. And because of the exothermic reaction, the ignition temperature of ammonia will be reached in due time, and hence it can be used. Moving ahead, the slow chemical kinetics. We can use catalysts such as sodium chloride and barium chloride in order to enhance the performance of ammonia. The NOx emission from ammonia is again an inevitable part of ammonia. We can use the latest retrofits of selective catalytic reduction, which can reduce NOx emission by close to 95%. We cannot use the traditional old manufacturing Haber-Bosch process for the production of ammonia. So I have proposed 3 different methods that can be used, beginning with reverse fuel cell technology. This is a simple technology in which hydrogen is produced at the cathode during the electrolysis of water and O2 at the anode. And then nitrogen is reacted with the hydrogen produced at cathode to produce ammonia. Moving ahead, this is a wind turbine system where we use the electricity and the electrolysis of water, we get hydrogen, and nitrogen can be easily extracted from the atmospheric air. And then reacting these two in the ratio of 1:3, ammonia can be synthesized and hence stored. Moving ahead, again, ammonia is a new fuel, so there needs to be several engine modifications that needs to be made. A large fuel storage capacity is required. Compression ratio should be very high. And dual fuel injection, we are already using the dual fuel injection, so that won't be a problem for us. Appropriate selection of material because of high ignition temperature of ammonia. We need an auto control fuel blender to maintain the air fuel ratio. And then ammonia should be preheated. That is a must before injecting into the engine. Now, green ammonia. Green ammonia is an ammonia which is 100% renewable and carbon free. It uses solar wind energy to produce electricity that feeds an electrolyzer to extract hydrogen from water during the electrolysis, and nitrogen, as earlier said, can be separated using the air. Now, green ammonia stakeholders. Even Indian Prime Minister Shri Narendra Modi in his speech in the latest UNGA, United Nations General Assembly, envisioned to cut the fuel imports by 2046 and to go carbon free by 2070, and thus making India a global hub for green ammonia. Even the Australian government has received an initial funding of nearly $200 million to become the world's largest exporter of green ammonia. Saudi Arabia is also working in partnership with US Air Products to produce a massive 4 gigawatts of electricity for electrolysis of water. Wärtsilä and Man Energy are also working, testing their 4-stroke and 2-stroke ammonia engines. Moving ahead, now concluding my presentation, ammonia is one of the most highly produced chemicals. It's producing over 180 million tons per year. Just by using ammonia, we can decrease the carbon emissions by 3 to 0.9%. And if we use green ammonia, definitely the number will come down to 0.3 to 0.5%. And hence, it's just a matter of time where the future of shipping will be completely transformed. Testing is in its initial phases at various shipping companies. And again, we need to think something out of the box, or rather, we should accommodate alternative fuels in our box. And hence, the governments, the shipping companies, the charterers, the small startups, everyone needs to come together to have an ammonia-propelled future. Thank you.
Thank you, Mumbai 1D2. Thank you for sharing all the work which you are doing on green ammonia. I now open the floor. While I open the floor, okay, I see that hand has dropped. So I first call upon Chennai C1 to have their intervention. Chennai C1, the floor is yours.
Yes. And Team D2, very well presented paper. And this supports our claim that e-ammonia is going to be the future for shipping industry. And in case of ammonia that we use pilot fuel, spark ignited engines can be used with pure ammonia as well. So that would be my input.
Very
Thank you.
Very nice, C1, and I'm sure you can have common grounds to discuss and take your mutual researches forward with common aligned interests. Interesting to see that. E2 Mumbai Zone 1, the floor is yours. Okay.
Respected Chair, I have a question that now they explained that the production of the ammonia is by other different ways. So mostly the industrial production is done by the outcome of CO2 will come. So that's why they are giving the green ammonia system nowadays. So my question is that when it is coming to our marine field, many issue can come. Many of this production people can change by the system, and they can produce by the existing gasification process only. So the pollution will be there because they can manipulate the system. So their production can be either the gasification. So how we will resolve this issue to stop them for producing this gasification and only by using this electrolysis method? How can we ensure
Again,
the pollution free?
I am sure that is a concern. Like finally, it's the common goal of all member states to ensure that pollution is prevented, and thus there would be legislations both at international and national levels to take care of that. Anything you would like to add on to that, D2? I can give you the floor. Please go ahead.
nothing, sir. It's exactly the same answer. Just I want to add that even the latest artificial intelligence, even that has some drawbacks. So we need to work together. The governments needs to come together, allow concessions, and then we can plan for how to control the pollution. It's not an overnight change. Everything takes time. So yeah, that's it, sir.
Thank you very much. A3 Mumbai Zone 1, the floor is yours.
Respected Chair, my question for D2 Mumbai Zone 1 is that in one of your slides you have mentioned that the space required for the storage or tank for the ammonia, it's going to be increased, it's going to be more. So don't you think that it is a concern for the ship owners that they will be able to carry less load compared when they will be using this system? Less cargo.
Definitely.
Yeah, D2, you like to respond to that?
Yes, sir.
Yeah.
That's the concern for everyone, but we cannot compromise the environment just for a mere profit. Environment is first. Definitely, we don't want to suffer from diseases, respiratory diseases and all, as I said in my slides. Again, I do agree that the storage space required is a concern, but again, just for mere profits, we cannot risk the environment.
Thank you, D2. I see A3 Mumbai Zone 1 wants the floor. Okay, A3 Mumbai Zone 1.
Yes, sir. So my question to D2 is, the well-to-wake emission will have some value. So how are you going to deal with that?
Sorry, according to our team, like we are not dealing with the well-to-wake and tank-to-wake technology right now. We are just going with the direct production of ammonia.
Okay.
Thank you.
Thank you.
Okay, you have brought up the question of well-to-wake. But when we talk of green ammonia, maybe you can get in detailed touch with the research division and find out, because if renewable energy is used, then it would automatically get covered up in the well-to-wake calculation. Of course, we are not talking of gray ammonia. We are talking of ammonia. Yeah. So, thank you, delegates. Thank you for your interactions and listening to further one more member state looking at ammonia as an alternative solution. I now call upon Mumbai 1 E2 to present their paper. Mumbai 1
Thank you,
E2,
sir.
the floor is yours.
Thank you, sir.
Are you having some connectivity issues?
No, sir. I'm just sharing my screen.
Okay.
Is the PPT visible?
No, not yet. Yes, it's coming
Is the
on now.
PPT visible now?
It's coming on now. Yeah, go ahead.
Yeah. Okay. Thank you. So, good morning to one and all, respective dignitaries, chairman, and respective teams. So, This is Team E2 from Mumbai Zone 1, and we would like to present our idea on reducing the greenhouse gases emissions from ships, and that is the use of a marine electric boiler. So myself, Ajit Nair, and my team members Akshay, Harikrishnan, and Jitin. So we all know what an oil-fired wide boiler is and how it works, and what are its perks and its disadvantages. So I won't go much to talking towards that. So I'll focus on what our electric boiler helps us with. So as you can see, it gives us a hassle-free environment. It is much cleaner. It is compact in size. It is easy to operate at, as it is an electric boiler. You just need to use an MCCB, just an on and off switch can help you operate it. There's no much need of competency required for this, and the installation is also very easy, and you don't have any fumes as we use electricity. There are no emissions. There are zero emissions, to be exact. So as you can see, the sulfur time limits timeline here, it shows like where we were and where we are now. So we can improve this much more further if if we have the use of an electric boiler in our case. So we are striving towards a zero emission area. That is what even IMO is striving towards. As you can see, there is a huge gap that from where we have started, where we want to be, and where it is actually in the present scenario. So that emission gap is what we have to reduce, and that is the sole purpose that we have such a convention or such a session over here today, so that we can bring up ideas, to discuss and to inculcate to reduce these emissions. So I believe that our proposal of the electric boiler can really help us move forward with this, reducing the greenhouse gases. So these are a few principles and characteristics of an electric boiler. So as the name itself states, an electric boiler, we use electricity to produce the steam, where in a conventional boiler we use fuel, or even when the ship is running we use the EGP. So what happens here is that we have two electrodes, and we use the resistive and the conductive properties of water to actually produce heat and heat the water and produce steam. So in between two electrodes, we have water passing through it, and which completes the line circuit, and it actually because of the resistive property of water, it gets heated up, and the steam is being produced. So the main advantage of this, one of the advantages is that even though the boiler is on, unless and until you provide or you give a feed of water to this boiler, it will not start producing. So that is a main plus point. So these are a few characteristics that I've already mentioned. It is very easy to maintain, and there are no combustible products, so that adds to it. So this is just an e-boiler for a pictorial representation for your reference. So these are the parameters, like you have various capacity of e-boilers, you have various types of e-boilers. So with respect to the capacity, or with respect to the need of the vessel, you can choose your respective e-boiler and then use it accordingly. So the effects of pollution that conventional boiler gives is there are a lot of emissions. There are a lot of greenhouse gas emissions like carbon dioxide, carbon monoxide, and whatnot. You all know, we have all heard this for a long time, for years and years. So you all know what happens when we burn fuel and what are the emissions and what causes it. So we have actually brought in some methods to reduce it, like we have got in some such certain regulations, like in ICA we need a lesser amount of SOx emissions. So we have been as our friends have spoken about different alternate fuels, we have been changing that. We have been from HFO, we have been going to VLSFO, we have been going to ULSFO in order to reduce the emissions. So these are measures, but there have been limitations to it. So my proposal would be that an e-boiler use of an e-boiler would be, there'll be zero emissions even when we're using it on in ports, we'll have zero emissions. So it is a way forward, is what I believe. Over to you, Hari.
So thank you, Ajit. So to the respected chair, I am proposing a paper, the marine electric boiler. As we all know that on voyage the ship will produce steam on basis of the exhaust gas boiler. So on port and anchorage, we only use the oil-fired boiler or the combustion. So if in a port where the onshore power supply is available, then the diesel generator is off. So completely ship is off on combustion. So no combustion is taking place except this oil-fired boiler. So if we are replacing the oil-fired boiler to an electrical boiler there, so the ship is completely eliminating the combustion from the ship. So elimination, the GHG elimination, GHG emission is completely eliminated. So using a marine electric boiler, we are proposing this paper to take marine electric boiler on board, which is very effective for the reduction of GHG. So as we all know that fuel consumption per day of a marine oil-fed boiler is 1.1552 ton. So advantages of marine electric boiler is that while we are proposing this project, we got to know that the European ports are going for within 2028 they will equip to the onshore power supply because they want to reduce the emission in their port as well as on their anchorage facility. So while using marine electric boiler, we are completely eliminating the emission in their ports and also in anchorage. That's the main thing, advantage of using the marine electric boiler. And also in our country, the developing country, we don't have the fuel or extracting the fuels. So in this in this country, we are more depending on the natural resources. So from well to tank also, the production of electricity is also based from natural resources. So it is also reduction of the GHG emission. So we are proposing to take the action accordingly that if the European ports are doing to start the onshore power supply on their ports, so we request IMO to make regulation and guideline to start this onshore power supply facility in all the ports of all country. And also if marine electric boiler, this onshore power supply is available in all the country, then it is far better to the production of marine electric boiler and it can be established on board ship very efficiently. So finally, what we all are talking in this presentation is simple that marine electric boiler, if we are placing marine electric boiler instead of an oil-fired boiler, we can eliminate the combustion from the oil-fired boiler. So it is far efficient, and also the European ports are also supporting our paper by they are establishing the onshore power supply in their ports within this time period. Thank you.
Thank you very much, Mumbai 1 E2, for a concept. Before I hand over to the floor, I, as chair, understood you talked about inside the port. What would happen at anchorage? At anchorage, how would you deal with it? Will you have two boilers, or are you doing some research to have a sort of a boiler which could either run on fuel or on electric, depending on what is available?
To answer your question, we can actually use the same electric boiler itself during anchorage, and with respect to our calculations, taking a real-time scenario of the fuel consumption of an oil-fired boiler, the electric boiler would consume a lesser amount of fuel even if it is run with the use of a generator. So we can use the use of generators as in most of the ships now. It also depends on the size of the ship, how many generators it is being equipped with and the capacity of the generator. So most of the ships we have at least 3 generators or at least 2 generators minimum. So we can run those generators during the anchorages. But the main thing now that the vessels or the companies are focusing upon now is they are slow steaming. They want to reduce the amount of time that they spend in anchorages, because it is they have to pay for that. They have to, it is still rising. The amount, the price is rising. So they want to reduce that. So most of the vessels are going for slow steaming. So that itself is, helps for our, purpose of boilers, so that we are reducing the amount of anchorage stays, so that the use of boilers in the anchorage is also less, even though it consumes lesser fuel.
Thank you. I'll now take
Thank you.
the questions from the floor. C1 Chennai, the floor is yours.
So, Team E2, it's a very good concept, and I agree with the concept that electric boiler will give you zero carbon emission. But to generate such electricity, we'll need renewable energy or any alternate fuel that will give us zero carbon footprint. And since alternate fuels are already being introduced into shipping, and I think oil-fired boilers must be phased out. Thank you.
Yeah, I agree with your point. And even now, most of the, like around 70% of the ships are being equipped with the ULSFO. So the requirement of steam is also less, but still you cannot, remove out a boiler just like that, because you still require steam here and there for at least for the accommodation purposes, or for ice class ships, for example. So you cannot avoid the use of a boiler. So boilers are still being used, and it cannot be, removed out as in a whole. So by proposing the use of an e-boiler, we are thereby, decreasing the emissions that actually gives us zero emissions. So when replacing it with a conventional oil-fired boiler, you have, a considerable difference of emission standards.
Thank you, E2, for your clarification.
Thank you.
I see E2, some other member has his hand up. You want to add on something to what has been said?
Yes,
Okay,
sir.
go ahead.
Sir, the chair asked one question about the anchorage. So I want to support my paper on that question itself. That so some of the ports, European ports, are also giving sponsored power supply in the anchorage also. They are providing some battery, some barge type system in the anchorage also, to provide the electricity in the anchorage facility also. And also the same thing, that now the anchorage is limited because of the, to reduce the anchorage to cost to pay the anchorage facility. So I want to add that point also. Thank you.
Great. And I'm sure if electrical vessels also come in, that could also align itself. Okay, D2
Yes,
Mumbai Zone 1, the floor is yours.
I have one question for you too. If we use electric boiler, we obviously need electric heaters. So what kind of electric heaters are you proposing to use?
See, it is not a necessity that you need electric heaters. Like electric boiler is itself a kind of a heat exchanger. It gives you heat. It gives you, because of the resistance properties of water, it helps generate heat, and the water is being heated and it produces steam. So that is, I believe, it is a different aspect to what we have been talking.
You want to add on something?
Yes, sir.
Yes, please go
Yes,
ahead.
Chair. I want to add on. I think his question is that what type of boiler is used on our concept. That I think we are using not the winding type. We are using the electrode type. It is more efficient to produce high capacity steam production on board ship to tanker ship also. That much amount of steam can be 45 ton per hour can produce.
Yes.
It is available on our shop.
Yes, I think some details are there in your paper. You could. Some details are available in your paper. You could share some research during the coffee break with the team.
Sure.
Meanwhile, A3 Mumbai Zone 1, the floor is yours.
Thank you, sir. My question for E2 is like, what if the boiler is on and no water is being supplied? So are there any safety measurements that are being taken to prevent such kind of scenarios?
Yes,
Before I check, sorry, you want to come back on that, E2?
sir. After you, sir.
Yeah, okay. Uh, if you want to respond to that, okay, go ahead.
Actually, it is a safety measure by itself. Is that unless and until you provide water to it, uh, there's no conductivity happening. The circuit is not complete unless and until you provide water. So even if the boiler is on, it itself, it acts as a fail safe that there is no the circuit is not complete, and hence there is no issues that is being that will affect in any operation. Yes.
Yeah, I think, and your colleague delegate wants to add on to that. Go ahead.
Yes, sir. I want to support our paper that for oil-fed boiler, if we are using the oil, the most of the energy is also exhausted out also. So here, a thick insulation is given to a boiler, so complete energy is utilized. So the emission is also high and the efficiency is also less in compare in oil-fed boiler. So it is very good for very good compare in electric boiler.
Thank you.
Yes.
I have the hand of C1 Chennai now. Yes, C1 Chennai, go ahead. The floor is yours.
Sir, my question is about what are the safeties of e-boilers? Like if in case of any short circuit or something like, what are the safeties
Okay,
provided
so
in e-boiler?
looks like you have got another member interested in your project. So I'll give you, can you answer in brief and then later on discuss in detail, which I'm sure technical matters can be discussed. But in a brief, if you want to take up E2, go ahead, the floor is yours.
Sir, in short, I will tell about that. Sir, marine electric boiler is completely a electrical system. So on board ship, electrical safeties are very high. So MCCB, MCB, and also the resistive system, insulation system. And when water is not there or the supply is not there, it automatically cut off. If the pump is off, it automatically shut off. So electrical system are more efficient. So the safety part for electrical part is very efficient than oil fire. Thank you, sir.
Yes, I'm sure then, unless you have got anything very specific to add, we would now take a break. Is there something specific, E2, you want to further add?
Yes, sir. Yes, sir. Just a single point. That is, we already have a lot of automations that is happening on board our vessels. So we have a lot of safety features for the respective electrical items. So the same thing can be applied for the electric boiler. You have the use of ACBs, you have the use of MCCBs, you have the use of MCBs, you have the use of the IRM meters. So the same thing can be applied for the electric boiler as you use it for normal electrical devices. Thank you.
Thank you very much. Thank you, gentlemen and ladies in the audience. I do not think any of the teams had a lady member. If they had, I'm sorry. In that case, ladies and gentlemen, thank you for your interaction in this first session. I'm sure the judges have a tough time ahead of them looking at your presentations, your views, innovative ideas, suggestions. At the moment, we'll take, I am allowed by the MC a break of about 15 minutes. Is that correct, Mr. Gaurav?
That's right, 15 minutes.
So we will assemble at 10:45 when I'll conclude this session. And thereafter, we'll be having a short tea break and we'll be starting our second session. Or could we, I think let's do it like that. So you can get your teapot on and after the summarization, you can start having the tea. So with that, we take a short break. Thank you, ladies and gentlemen.
Right, there was a need for this technical break because the session chair has to prepare the summary of the session, which he will deliver after 15 minutes. After that, we'll have a short 10-minute tea break. You can have your tea now also, and then we'll start the second session after the tea break.
Welcome back. We will be starting in about a minute. Is that okay, Gaurav?
Absolutely.
For judges also it is okay.
Thank you, sir. A very good morning again, and welcome back to all the delegates and the judges, guides, and the coordinators. It's been a interesting session in the morning. We had 4 member states. A couple of new innovative ideas came across. Mumbai 1A3. Came up with an innovative idea of waste heat recovery and changing the place where air conditioning, etc., could be converted using waste heat recovery. Thank you for your innovative concept. While you do more experimentation, I am sure member states would like to keep hearing more about where you are doing further research, and we would like you to share your further developments on this with the member states, so that as one of the mechanisms where waste heat is utilized and obviously then adds on to all efforts of everybody to not waste anything, takes it forward. So we look forward to hearing from you. Another innovative concept came on changing the design of boilers on board the vessels, considering the new developments taking place. We would also find that there are people getting interested in this innovative concept. Thus, as you develop more information on this type, or do any prototype testing or any other development, kindly do share at next session so that it can be taken forward. The other 2 members aligned themselves on their view of using ammonia, green ammonia, especially even using green ammonia as a carrier of hydrogen, which can then be adopted as a fuel. We see a lot of synergy happening in that field. While the Chennai team gave a specific project of Thulukkudi ski project example, where solar energy is being used. I hope I got my pronunciation correct.
No, it is Thoothukudi.
Thoothukudi, okay.
Yes.
Thank you, sir. So, as more research develops, such projects come up, it would be great to hear more developments on this aspect coming forward from the member states, for information of other member states who can take this up forward. And thank you for bringing these ideas, information, and ongoing projects going on in your respective member states. And we look forward to hearing more from them. And I think now we can take a well-deserved tea break. Thank you very much.
Coming back on this Thoothukudi, the English did not pronounce it, so they called it Thoothukudi. And it has come back to Thoothukudi back.
Okay.
Because the Indians are back. The English are gone.
Sir, we learn something new every day, sir.
Thank you.
Thank you, sir. Thank you.
Thank you very much. We will be reassembling at around 11 o'clock onwards to commence the second session at 11:04 sharp. Thank you very much. Over to you, Gaurav.
Thank you so much.
So we have 20 minutes.
Thanks for the chair for nice summary. Thank you so much.
Mr. Datta?
Yeah, I just want to know this group, how many papers you are going to be?
6.
Five.
That means 5 plus 4 plus 5. Then
We have just completed 4.
yeah, then
Now, in this group, there will be 5.
okay.
Then after lunch, there will be
4 plus 5.
4 will be 4, and then 5 again. Total 18.
Okay, 4 plus 5, 4 plus 5. That means when this next session will start, only 5 participants were going to make interventions. Rest of the people will not make any intervention. Is it correct?
Correct.
Okay, fine. Thank you.
You have to answer that.
Yes, amongst those 5 participant teams, they will be making interventions.
So that means Rajiv from Calcutta A2, Calcutta C1, Calcutta D1, Calcutta D2, and Calcutta E1. These are the 5.
That's right.
Calcutta A2, Calcutta B1, Calcutta A2, Calcutta C1, Calcutta D1, Calcutta D2, and Calcutta E1.
Okay, fine.
Yeah.
Mr. Chair, you have taken 5 minutes of our time, so please give us up to 7:05. if you don't mind.
Okay, sir. Please enjoy your tea.
We are ahead of time, sir.
Thank you, sir.
Right.
Right.
Tea break, gentlemen.
Yes, sir.
Yes, sir. You can, Manoharaji, you can finish.
बाद में खा नहीं बेटा बाद में खा लेंगे मैं तो बैठे बैठे भी वही खा लूंगा बेटा हाँ तो नहीं तुम कभी
Mr. Mehrotra, you wanted to come in on something?
What happened?
No,
by mistake I must have raised hand. I'm so sorry.
Maybe I just came back on. I saw your hand. I saw something.
By mistake. Sorry.
Right, Rajiv,
Yes.
shall we end the tea break?
I think as per program, you had given me 11:04.
11:04, that's right. My mistake. You came back, that's why I thought.
I'm just putting the program back on.
Yeah.
Gaurav, I think you can start introducing the teams which are there this time.
Okay, ladies and gentlemen, welcome back. We now start session 2 of MEPC, of the MEPC semi-finals. And in session 2, we have 5 qualified teams. That is team Alpha 2, Charlie 2, Delta 1, sorry, Alpha 2, Charlie 1, Delta 1, Delta 2, and Eco 1, all of Kolkata zone. The Kolkata zone guide is Mr. Sunayan Sanatani. Mr. Sanatani sailed for 12 years after passing out from BMET in 1986, and he joined IRS in 1998. After around 10 years in IRS, serving in their service stations and the classification department at HO, he joined Great Eastern Shipping in 2008 and is presently serving as state manager. A fellow of the Institute of Marine Engineers, Mr. Sanatani is extremely active in alumni affairs of BMET. I now hand over to the session chair, Mr. Rajiv Nair, to conduct the session. Over to you, Rajiv.
Thank you and welcome to all the delegates of second session. We now commence the second session. 5 member states are represented out here, and I will call upon Kolkata A2 to kindly commence their presentation.
Good morning, everyone. I'm Cadet Weber Mishra, along with my teammate Cadet Yash Shankar, Cadet Shubham Roy, and Cadet Yash Pandey. We are currently pursuing our BTech degree program from Indian Maritime University, Kolkata campus, and we are presenting Developed Nation under the topic of reduction of greenhouse gas emission from the ship for MEPC. Let's talk about the index of our presentation, which is we will first talk about the introduction part of our topic, and then we will get to know about the effect of greenhouse emission and how to reduce GHG emission. Then we will further discuss about the reduction of GHG outflows, then what are the alternative fuels, what are zero carbon fuels, and then we will talk about the references and conclusion part of our presentation. So in introduction part, as we all know that greenhouse gases, also known as GHGs, are the gases in the Earth atmosphere that trap heat. On a very simple level, the greenhouse gas effect is the name of the process for where certain gas trap heat in Earth atmosphere and contribute to the warming of the planet as a whole. The main greenhouse gases whose concentration are rising are carbon dioxide, methane, nitrous oxide, hydrochlorofluorocarbons, and ozone in the lower atmosphere. Let's talk about the effect of greenhouse emission in the next slide. In 2020, US ozone hurting substance transmission amounted to 5,222 million measurement bunches of carbon dioxide, partner directly following addressing sequential from the land origin. Outflow reduced from 2019 to 2020 by 11%. The fundamental driver for the decay was an 11% lessening in CO2 surges from a non-environmental friendly power sources start. This decrease was a result of 13% decrease in transportation releases driven by lessened demand because of consistent COVID-19 pandemic. The electric power region releases moreover reduced by 10%, reflecting both a slight decay well known from the COVID-19 pandemic and a continuous shift from coal to less carbon concentrated various petroleum and renewables. In next slide, we will talk about the how to reduce GHG emissions. There are various ways to reduce GHG outflows. The IMO found that a speed decrease of only 10% would accomplish a 23.3% decrease in release. The speedier naval forces consume 140,000 assembled piles of fuel. Then again, the more listless fuel consume 60,000 measurement heap of fuel. A lessening of 50% in fuel use in and this way conveys cleaner power like marine diesel oil contain 0.5% sulfur, while a marine gas of oil contain simply 0% sulfur. The IMO extend a change from significant fuel oil to marine diesel oil would bring about a 4 to 5% decline in carbon dioxide created per metric ton of fuel consumed. Such a switch could, in like manner, decline nitrous oxide over 91%, particulate matter by 63%, and nitrogenous oxide as a bundle of very nearly 5%. As we all know that we have a chart on the presentation, which is the country who is the member of OECD, which is the Organization for Economic Cooperation and Development. The country which follow the policies and propaganda of OECD have the less carbon emission, which have the record of 2010 to 2050. And the country which are a part of OECD are some countries are United States, Australia, Chile, France, Denmark, Japan, India, etc. There are overall 38 members of country which are a part of OECD. In the next slide, our team member will represent about the reduction of GHG outflows.
So, I am Karadia Shankar, continuing over this topic on reduction of GHG outflows. To make a zero-emission transporting Amanda, new propellers should be created alongside clever drive frameworks, updated vessels, and a completely new worldwide refueling organization. For a boat to zero outflows and other ozone depletion substance, the area is investigating a scope of zero discharge fuels and innovations, including batteries, responsible biofuels, and green or blue hydrogen and their substances, like smelling salts and methanol. Blue hydrogen is created from flammable gas by dividing its particle into hydrogen and carbon dioxide and catching and putting away the CO2. In meantime, various delivery organizations are beginning to define their decarbonization objective that go to past IMO objective. One of the biggest delivery organization on the planet, AP Moller, Maersk, intend to accomplish net zero fossil fuel products by 2050 and has in between time focus of 60% decrease by 2030. So coming on the next slide, which is alternative fuels, which will be presented on the screen. So petroleum-based fuels currently make up over 90% of the fuel used for transportation and emit high amounts of greenhouse gases. Alternative fuels, any fuel that is not petroleum-based, are looked as a potential solution for reducing greenhouse gases emission. Example of alternative fuels include biodiesel, ethanol, electricity from renewable sources, propane, and hydrogen. In delivery, expand utilization of considered petroleum gas, LNG, and methanol gives expected expanse to arrive at low carbon transport. Melted petroleum gas is progressively embraced as a marine fuel, likewise for ships other than LNG transporters. This specialized agreement frequently incorporates a double fuel motor that can run on either LNG or fuel oil, or which generally utilize a minor measure or fuel of oil that start while utilizing LNG. Industry transport in district with a laid-off framework or LNG will be a more effective take or LNG as a fuel. So coming on the next slide, which is zero carbon fuel, which will contain some electrofuels, otherwise called e-power or manufactured fuels, a kind of drop in substitution fuel. They are produced utilizing carbon dioxide CO2, carbon monoxide CO, along with hydrogen that got from renewable sources like wind, sun-oriented, and atomic power. Applied to oceanic vehicles, these e-powers come in two structures, either as e-hydrogen, e-ammonia, which requires new vessels and new frameworks or transformation of existing ones. Second, as e-hydrogen, as e-diesel or e-LNG. Now let's have a look on e-ammonia, mostly oriented from fossil fuel-based hydrogen. Ammonia carries the potential to be extracted from carbon-free sources. This is an avenue currently explored by the scientists for the production of renewable fuels at low energy density of ammonia, along with the highest shortage volume. Although this is highly corrosive potential poses some health and safety risks. Now let's have a look on hydrogen being a non-toxic gas, hydrogen provides some added benefits for all other fuels and carbon-based options. At lastly, we will talk about methanol, which is derived from the natural gas or coal, as well as from agriculture waste or renewable sources. Methanol is regarded as one of the most sustainable marine fuels alternative. So at last, let's have our topic on the conclusion. I would like to conclude my PPT by saying that the outcome demonstrates first that e-fuels will be exorbitant with extra expenses relying generally upon inexhaustible power costs, affirming comparable discoveries from past distribution. Moreover, the current review shows that the cost of the different e-power relies particularly upon the power cost. In low-cost situation, e-diesel, e-LNG, e-methanol turns out to be the more cutthroat, which is the most energy potential e-fuels. Thank you. So the next questions will be, so we are ready for the questions and the questions will be taken by Cadet Yash Pandey.
Thank you very much, Kolkata A2, for all the information you have been able to give us about various types of fuels. Before I open the floor, or let me first open the floor, then I'll come to my sort of a summary comment. I open the floor and I would again request delegates from a particular team to consolidate their views and come back with a consolidated intervention, which would be time saving. Otherwise, it is going to impinge on the time of the forthcoming presentations. So I open the floor to D2, Kolkata.
Thank you, Chair, for providing us with the floor. And first of all, I'd like to congratulate A2 Kolkata for coming up with such a wonderful presentation. And we would like to, we do appreciate your research. And we have three primary concerns which we would expect further elaborations on. Number one is, as mentioned, you plan to use biofuel in the shipping industry. The question which I have, or the question in which I would be expecting further elaboration in, is how exactly do you plan to initiate the mass production of biodiesel in the fuel industry, because it is something which requires major infrastructural overhaul. The second point which I'd like to draw is how exactly do you look at slow steaming or reducing the speed of ships in the long term, because as per the research of the industry stalwarts, it is not a long-term solution. And the third point is how exactly do you plan to curb methanol slippage while using methanol as a fuel? Thank you.
We are talking of methanol slippage or methane slip. If you could kindly clarify what methanol slippage you are referring to?
Sir, while using methanol as an alternative fuel, there is a phenomena where the unburnt fuel combustion is stayed there, which results in
Okay.
Which, yes,
we will also look up that at the secretariat, because we were aware of something methane slip in LNG. We will check up at the secretariat at the back end also. No problem on that. Meanwhile, I do not see any other hand on the floor as yet. So I will let A2 respond in brief, because I am not very sure, but that was a point which I wanted to make. I came across a lot of information on the various options, but I was not very sure if there was any particular one which was asked as a way forward. Anyway, I'll leave A2 to clarify on the queries of D2.
Yes. See, biodiesel fuel is a renewable form of energy. It can act as a lubrication for the moving parts of your engine and to improve the performance of your vehicle or equipment. Nowadays, diesel cars produce a lot more of NO2. Diesel engines can be slightly noisier nowadays. If you don't drive on motorways regularly, your diesel particulate filter, that is DPF, could get clogged up, and this can be expensive to put right. So using biofuels in place of petroleum diesel cycle carbon.
I'm sorry, I think A2 we sort of having some communication. Is he audible?
Yes, sir,
hello.
we are audible, sir.
Okay. Please go ahead.
So biodiesel fuel is a renewable form of energy. It can act as a lubrication for moving parts of a engine to improve the performance of the vehicle or equipment. Nowadays, we can see that diesel cars produce a lot more of NO2. That is, diesel engines can be slightly more noisier. If you don't drive on motorways regularly, your diesel particulate filter, that is DPF, could get clogged up, and this can be expensive to put right. Using biofuels in place of petroleum diesel, that is significantly reduces life cycle carbon emissions.
Yes. Thank you, and I am sure your research on cars and all, when you convert to maritime sector, you would be able to share information on that, because we would be interested in the progress towards a maritime field. So as you progress with further research on that, that will be helpful. Meanwhile, I see the hand of D1 Kolkata. D1 Kolkata, go ahead.
Yes, sir. Sir, I have a question for A2 Kolkata zone. That how will you replace all currently running ships on HFO? Because we know that most of the ships are currently running on HFO. So how will you replace them with your
Yeah.
idea?
See, HFO, that is heavy fuel oil, has been a logical choice for ships because it is very high in energy. So a little takes a ship a long way, and it was inexpensive. It is cheaper than other fuels because it is leftover, or the residual product from the oil refining process, that is HFO, could also be used as a purifier by replacing the gravity disk, which is smaller than the heavy oil.
Thank you. I see the card of E1 Kolkata. E1 Kolkata, go ahead.
Yes, sir. Sir, I have a question for A2 Kolkata zone. Sir, as mentioned in the paper, they are basically implementing e-fuels. So production of e-fuels is quite expensive and at the same time fluctuating. So how can they overcome this problem?
A2, you would like to respond?
Yes, sir.
Go ahead.
So, see, the cost of 1 liter of e-fuel, which is cost around $2 USD. So let us consider a electric power station and or a gas station in which we need to develop, buy infrastructure, maintain it, operate it, and we have to give electric demand charges and other fuel taxes or other fees collected. In some states, we can see that we don't have to give in marine sector on ship, so these prices are lower than at most public or commercial power stations.
Thank you, A2. But as I stated earlier, it would be very helpful. It's good to know the work you are doing on e-fuels. And once you are able to translate it into marine field, it will be great if you could share the further information which the marine sector would be looking for in anticipation to be able to take forward. Seeing no further comments on the paper, I call upon Mr. Ramamurthy. Yes, sir. Please go ahead, sir. Sir, you are on mute, sir.
This methanol slip. Methanol has got the lowest reforming temperature, which is up to about 280 degrees centigrade or so. So probably he's mentioning about sleep in the reformer. That's what it is. Anyhow, what you said is right. Probably have a better look into that and do that. But probably there's a confusion between methane slip and methanol slip. Methanol slip takes place in the reformer because it's the lowest reforming temperature. Just to give what I know about this. Thank you.
Thank you, sir. As I said, we keep learning every day. We'll also, at the Secretariat, get the details of this because, yes, methane slip is definitely under consideration for LNG. Methanol slip also we'll start looking at. D2, you want to come in with something?
Yes, sir. We wanted to let you know that this is exactly what we were talking about, the methanol slip in the reformer.
In the reformer.
Yes,
Okay.
sir.
Okay. So it is not in the engine, but in the reformer.
Yes.
Okay. Thank you. Thank you very much. Thank you, Ramamurthy, sir.
Oh, thank you so much.
So I call upon Kolkata C1 to now take the floor and present their paper. Kolkata, are you starting? Kolkata C1?
I think there are connectivity issues.
Sorry for the inconvenience, sir. We are starting shortly. We are facing some connectivity issue.
Would you like me to move on to the next presenter? Meanwhile, you sort out your issues, or would you like to just try again?
Sir, you can move with the next presentation.
Okay, then I'll call upon Kolkata D1 if you are ready to please start.
Yes, sir.
Please go ahead.
Good morning, everyone. In parallel, I'm team D1 from IMO Kolkata. I'm going to present my point of view on reduction of GHG emission from ship with my team leader Shashank Shekhar Jha and others. So, as my topic is reduction of GHG emission from ship. So, as my team leader is Shashank Shekhar Jha, and I'm cadet Shivam Thakur from Indian Maritime University, Calcutta campus, pursuing my BTech Marine Engineering. I'm currently in third year of my degree. So, as we know, the greenhouse gases plays a very important role in environment, as a greenhouse gas is a gas that absorbs and emits the radiant energy within the thermal infrared range, causing the greenhouse gas effect. As you can see, there is some parameters which we have shown in the slide, how much amount of energy is absorbed within the thermal infrared range and how much of energy is emitted by the radiant energy with the thermal infrared rays. So going to the next slide, we can have a look to the primary greenhouse gases in the Earth atmosphere, which is majorly as the carbon dioxide, methane, nitrous oxide, ozone, and fluorinated gases with some water vapors in it, as they trap the whole sun energy, which heat up the whole environment, and that's not good for our environment. So, as we know, from the shipping industry, which is growing right now, and there are emission of so many greenhouse gases from the ship. So, if we have a count and have a look to the greenhouse gases in 2020, the IMO 2020, 0.50% sulfur limit entered into force and cutting the total sulfur dioxide emission from ship by over 75%. And if you go to the 2021, then in June 2021, IMO adopted short-term measures to reduce the carbon dioxide intensity of all ships by 40% by 2030 compared to 2008. So as we have gone so far, so if we use the biodiesel instead of HFO and other fuels, that would be much more beneficial. And if we have a look to the next slide, carbon dioxide accounted for approximately 79% of total greenhouse gas emission in 2021, as we discussed. And without greenhouse gases, the average temperature of Earth's surface would be about minus 18 degrees Celsius, rather than presenting average of 15 degrees Celsius. few gases that we have discussed have shown in this slide. If we go to the next slide, we can have a look atmosphere concentration of CO2. The vast majority of anthropogene carbon dioxide emissions come from combustion of fossil fuels, heavy fuel oils as we discussed, which has been used on board ship, and principally coal, petroleum, with addition contribution from cement manufacturing, fertilizer production. That are few minor things, but as we are discussing the greenhouse gas emission from ship, so coming to the aspect of fossil fuels that accounting around the 80% of world energy need. We can have that percentage look. Gasoline is about 6.9%, coal is around 55.2%, natural gas come across the 37.9%. Most countries are also experiencing increasing international pressure on global warming issues. Renewable and clean alternative fuels are therefore required for current and further use. As we know, biodiesel is good candidate as a shipping fuel. Being biodegradable, non-toxic, and essential free of sulfur and automatic, it can be used in many marine applications with little or no need for engine modification. So if we have a look to the feedstock of biodiesel that count around the palm oil, soybean, canola oil, cooking oil, animal fat, which are biodegradable, as we can see. Biodiesel feedstock is highly dependent on climate and local soil condition. These biodegradable non-toxic fuels, which are shown in mind map we have discussed. So now we are heading towards the biodiesel as an alternative fuel, which we can ship on, which we can use on board to reduce the greenhouse gases emission as per the shipping IMO rule and regulation. We have to reduce that. That is, it is one of the promising alternate to fossil fuels due to environmental effect of petroleum fuel diesel engines dividing the petroleum resources. If we have a look to the biodiesel, which is formed from the natural oil and methanol. Natural oil we are using soybean, and we are producing that biodiesel from trans-esterification process. Biodiesel can be so beneficial for shipping industry in coming future that we can decrease amount like 5 to 10% of greenhouse gas emission in coming few years. So coming to the formation of biodiesel, if we process the methanol from catalyst mixing and palm oil from trans-esterification, after neutralization from neutralizing acid, we can head towards the phase separation of that catalyst mixed and palm oil esterified crude that results to the crude oil biodiesel. If we put some purification to that, we can extract some amount of biodiesel, which is going to be so much beneficial and economical. So there are different types of biodiesels which we can use as a fuel. So we can have a look. There are degradable and non-toxic. Product will be natural and renewable. As we discussed, palm oil is highly dependency for biodiesel. Like we can use it in different ways to produce biodiesel, and that has much higher efficiency. There are few developing nations, large producer of palm oil. Since 1964, that they have produced around 1,57,000 metric tons. And if you go to the year 2018, around 41.5 million metric ton has been produced. And in future plans, that the developing nations are setting a goal for 51 million of metric ton production of palm oil which we can use to produce that biodiesel. And the use of that we can use in different sectors also, that in if we go to the minor level in food industries, processed food production, hygiene products, cosmetic and etc. So as we whole discussed in this whole slide, if we coming to the conclusion, the presentation demonstrates how developing nation meet its goals of reduction of GHG emission by adopting biodiesel as an alternative fuel. Biodiesel has a promising future as a green alternative energy source for marine applications. Focusing on the marine applications, biodiesel fuel is blend of palm oil and animal fats, which is environmentally sustainable, non-toxic, biodegradable, and sulfur-free. Official mandates from the government and international energies, such as the International Maritime Organization, should encourage and promote the use of biodiesel in the marine industry. Thank you so much, sir, as for the given time. And yes, sir.
Thank you, D1 Kolkata, and thank you for stepping in a timely manner. Appreciate that, and bringing the points about biodiesel to the forefront for the consideration of other members. I now open the floor for interventions. Okay, D2 Kolkata, the floor is yours.
Thank you, Chair, for providing us with the floor. First of all, congratulations, D1, for coming up with such an innovative solution. We are in total favor of your proposal in this esteemed house, but we would love to seek further clarification on the fact that how exactly do you wish to curb this problem that the production of palm oil, like the solution which was presented was the generation of biodiesel from palm oil. So how exactly do you wish to curb the problem of the production of palm oil from other countries? Because as we can see in the presentation that the production is saturated in two countries, which are namely Indonesia and Malaysia. And also Indonesia is home to some natural calamities like earthquake, flooding, and volcanic activities, where we believe that the greater production would be in problem due to this natural curse. So how exactly do you wish to solve this problem? This is what we would love to see clarification on.
Thank you, D2. D1, would you like to respond?
Yes, sir. So actually, what he is telling that we are discussing only about means in prospect of Indonesian, Malaysian palm oil. So actually, biodiesel is not only made with natural oil and palm oil. It's also made from soybeans, animal fats. So there are abundance of there are abundant sources from which we can make biodiesel. And for other countries and for there are so many other things like soybeans. If we discuss about soybeans, America has abundance of soybean oil. So for every country there is something which is in abundance, and we can use it for biodiesel production.
Yes, thank you, D1. And yes, I am sure you should catch up and have discussions on the various paths for biodiesel, especially which do not disrupt food chain, because that would be one thing which would be of consideration, the grades of biodiesel depending on the source of the biodiesel, including used vegetable oils and all are also a source which is being used. C1 Kolkata, please go ahead with your intervention.
Yes, sir. So I'm audible, sir?
Yes, please go ahead.
Yes, sir. So thank you, Chairperson, for yielding us the floor. So we want to express our sincere gratitude to the team D1. And so our question is, can acetaldehyde and DDT be hazardous health demerits to living beings? as these chemical constitutes in biomass can cause cancer also. And as in that case, the source of biodiesel comes from plants and vegetable fat oils. If in case poor harvest will be there, and in any crisis, then how they will tackle the situation?
Would you like to respond to that, A2?
Uh,
Sorry, D1?
Yes, sir. So from various studies, it has been already shown that there is no such evidence of aldehyde exposure which is related to cancer in humans from biodiesel.
Okay. But if you have something specific on this, knowledge on this, you could come up and raise those queries in future sessions. A2 Kolkata.
Thank you, sir, for providing the platform for interventions. So my question for D1 MEPC Kolkata is what to do if nitrogen oxide emits in the higher range?
So if I understand your question correctly, you are saying with biodiesel, is there a chance of NOx increasing? Is that correct?
Yes, sir.
Okay. Would you like to respond to that, D1?
Yes, sir. Sir, for NOx, there are there are problems, but there are many different. As I told, sir, there are many types of sources from which these biodiesels came from. So I think, sir, there are various from other studies and from other research. There are various uh, various purification types from where which can reduce these NOx emission, and also sir, there are some different oils which are actually not increasing the NOx emission so much, so we can use instead of that if we found NOx emission is higher in any certain fuel which we are
Yes,
using.
and I can give some information from the Secretariat also. IMO does have guidelines on the NOx with respect to biofuels. While we can give you the written literature later on for those who are interested, up till B30, I don't think there is an issue. But beyond that, in case any NOx component requires to be, any component of the engine which requires changing of which impacts NOx, a NOx study requires to be done for higher percentage of biofuel used in the system. B20, B30, NOx is not an issue. But beyond that, yes, there are concerns that in case NOx, the engine is modified where some NOx components are changed, you do require to do a NOx study. I think some proposal in this MEPC will come up, which will require to put a streamlined method of using this assessment of NOx in place.
Yes, sir.
So from from the Secretariat, we can share this information with those who are interested. Meanwhile, I see the card of E1 Kolkata up. I see C1 Chennai has raised its hand, but you are not part of this group. So if there's something specific, I would request you to put it in the chat box and I'll have a look at it. E1 Kolkata, please.
Yes, sir. Thank you, sir, for giving me this opportunity to speak. So my question is, food prices will be altered with the scarcity of food commodities due to excessive biofuel production. So I would like to ask, how will you deal with this situation?
Exactly. Yes, sir. Exactly, sir. Sir, as the concern about excessive or food crisis, sir, let me again tell that these things are abundance in nature. Means there are certain areas where palm oil production is very higher. There are certain areas in which soybean production is very high. So I don't think there will be any type of food crisis. Food crisis is going on because of these biodiesel production.
Again, I'll share some information from the Secretariat in addition to what has been said by D1 for the information. When we consider life cycle analysis of fuels, there is a proposal to consider land mass usage factor also into that, so that it does truly reflect the state of what is the source of the feedstock going into production, especially on cases like biodiesel. So that should address some of the concerns raised, so that while we try to solve one problem, we don't create another problem. I hope that answers your query, E1 Kolkata.
Yes, sir.
Thank you for the bringing the biodiesel to light, which is receiving a push from many member states, and obviously there are a lot of questions on that, and we look forward to healthy interaction on that as we go further. If C1 is ready, can we take C1 back on? C1, can you raise your hand if you are ready, or I will move on to E1. Yes, okay, C1 is ready, so I invite C1 to present their paper to the floor.
Thank you, Chairperson, sir. Good morning and greetings of the day to the Honorable Chairperson, sir, Co-Chairperson, sir, and all the earnest delegates. We, the delegates of C1, are extremely thankful for the opportunity given to the draft and action plan reduction of GHG emissions from shipping. Shipping plays a vital role in economic growth and well-being. Excess of greenhouse gases in the atmosphere has led to global warming and climate change. No country is entirely self-sufficient. It is most significant contributor to the supply chain. Over the 100 years, the average temperature of the Earth surface has risen by about 0.8 degrees centigrade. Ocean acidity is increasing, ice sheets are shrinking, and sea levels are now rising twice as quickly as during the last century. Our action plans includes empty container repositioning. Carrier will have surplus of empty container at one port, but won't have enough container for a shipment from another port. So this means that the carrier has to reposition the empty container to the required port without any cargo inside. So an empty container takes up the same space as the full one takes, and the cost of moving it is also the same, and it all has done due to some factors, and those situations and factors are trade imbalance, condition in which particular ports, if export will be higher and import is less, or vice versa, it will eventually run out of container to the ship all of its cargo. Then we come to the time pressure. If export demands is very high in one region, carrier have to ensure that they have inner container at this port. So to fulfill the demand, we need to send empty containers to these ports as fast as possible. As we can see the graph that shows the export of empty container surge on high demand, and its value goes high in 2021 as it is due to pandemic, as from Asia side export is in very large scale as compared to America side. So our container export will be greater from our Asia side. And then we come to the storage cost, and also one of the factor, that is lack of cooperation between the carriers. And here are the solution proposed by us, that is reduce the movement of empty container, which include inland depot, in which we make temporary storage location for the empty containers. And another one was the container substitution, process of meeting the requirement of one type of container with another type of containers help in container substitution. Then we come to the point, that is port handling capacity, that is port handling capacity on CO2 emission index by reinforcing port facilities by blockchain having internet-based system for better synchronization among the shipping and transport companies. And another one is investigate the impact of empty container repositioning through strict policies for better analysis and for data accumulation. Now, I'm going forward. I would like to request the Honorable Chairperson, sir, to allow my fellow delegates, Cadet SM Shreyas, to proceed further with the presentation. Thank you, sir.
Go ahead.
Thank you, Chairperson, sir, for giving the floor. Now moving forward to methanol fuel cells. Now, methanol fuel cells is a flexible power solution that can be used for auxiliary powers or propulsion depending on the ship type and customer needs. Due to flexible form, the system is adaptable in regard to space availability and placement on the ship. The fuel cell technology is applicable for both smaller units as well as larger power auxiliary powers units in the megawatt range. When providing current, methanol is electrochemically oxidized at anode electrocatalyst to produce electrons that travel through the external circuit. You can visualize in the image that the circuit is within the cell by conduction of protons in the electrolyte. Now you can visualize in the screen where the anode is in red and the cathode is in green. And now speaking on usage of methanol fuel cell in shipping industry, methanol is available over 120 ports and is being used over 20 ships, making it fourth most used marine fuel globally. A methanol feed system may consist of pump, sensor, and electronics to monitor and clean the reactant before being fed into the fuel cell. Now moving forward to direct alcohol fuel cell, it is a subcategory of proton exchange fuel cells. These fuels have better blending ability, hydrophobicity, cetane number, and calorific value, making them excellent alternatives for diesel. The fuel is oxidized directly at surface of the electrode without reforming, which makes them attractive for portable power sources because the design of this system is comparatively simple. The operating time are extensive and the fuel can be easily produced from biomass. It is energy conversion efficiency for operation cell that can attain 30 to 40% currently. Here, proton exchange membrane and molten carbonate solid oxide fuel cell is found promising option for maritime application. The low operating temperature of fuel cell allow flexible and safe operation, less stringent material requirement, and quick startup. And now moving forward to Green Voyage 2050. Green Voyage 2050 project aims to transform the shipping industry towards a low carbon future. With this project, there can be expansion in government and port management facilities. It develops national action plan, catalyzes private sector partnership, promotes innovation, and etc. Now you can visualize on the screen. Here it depicts how to transform a ship to ultimate green ship by opting various interchangeable parts of the ship. And now moving forward to conclusion, in an ideal world, every shipping container would be full on every journey. So but in reality, this is not possible, as freight forwarders spend around $20 billion on repositioning empty containers every year. This is a massive problem in the logistic industry, and carbon behavior is one of the major problem in our environment. Speaking on alternative fuels, the industry requires a fundamental shift in fuels by moving more sustainable and renewable engine fuels to optimize the equipment. But technical innovations, vessel operation improvements, and planning will downscale the impact of emissions on the planet Earth by boosting energy efficiency and greener alternatives. Thank you all for patiently listening to us, and we are open to any kind of interventions for us.
Thank you very much, Kolkata C1, for bringing out the issue of empty containers and some innovative suggestions regarding fuel cells. Uh, I see the hand of Evan up. Evan, the floor is yours.
Yes, sir. Thank you, sir, for giving me the chance to intervene. So my question is, how is blockchain technology reducing cyber crimes?
Uh,
You want to know about cyber crimes? Specifically, I suggest since let us keep the focus on fuels unless it's got a relevance out here, you could possibly catch up on that in a tea break. Unless it's something very relevant and C1 wants to come back on it.
Sir, I have another question
Yeah, please
if
go
I
ahead.
can. Yes. Methanol cannot accurately be considered as a clean fuel since the center carbon atom always finds oxygen to pair up with. So why should one consider methanol fuel cell over hydrogen fuel cell?
uh,
C1, you would like to respond?
yes, sir. So I understand the concerns of Team Evans, and moving to its solution. Uh, uh, Drawbacks of hydrogen fuel is that hydrogen is much more lighter gas than methanol, which makes it difficult to store and transport. Methanol's advantage over hydrogen would be ability to use in existing engines and infrastructure with only minor modification. And if mentioning about methanol, there are fuels such as green methanol. Green methanol is a low carbon fuel that can be made from either biomass gasification or renewable electricity and captured carbon dioxide. Green methanol is environmentally friendly and can be used as energy carrier for storing the electricity generated for renewable sources or as a transportation fuel.
Thank you, C1. And if you have concerns on cyber security, even I would request you to put those across in the forum where the experts of that group would be sitting. I think they would be able to address the issue clearly. I now invite D2 to raise their comment. Thank you.
Thank you, Chair, for providing us with the floor. The proposal for the implementation of inland depots, container substitution, and container leasing are some really thoughtful ways of the mitigation of GHG emissions passively. And we believe that the strategic implementation of the same is of utmost importance. We'd thus like to collaborate with you and brainstorm some strategies which would ease in the seamless implementation of the same. Thank you.
Excellent. That would be good. A2, the floor is yours.
Yes, sir. Thank you, sir, for providing me the flow. My question for Team C1 is that the large number of bell fittings and joints in the fuel supply line and low viscosity of methanol lead to risk of potential leakage. So, how could we overcome with that?
C1, would you like to respond to that?
Yes, sir. Sir, as a major solution for avoiding safety issues due to leaks is to ensure the thermal fluid system and not operated in enclosed areas that have insufficient ventilation. If there are chances for a considerable amount of leak, sufficient amount of fresh air flow must be ensured in such location. That is, for example, we can put valve, pump, flanges, instrument, ports, expansion tanks, and flanges are major source of leaks in old and new systems. So therefore, leaking flange must be retort, close all the drain wall prior to the adding the fluid, and also to close all the block wall prior to opening a line, and isolating valves should be equipped in pressure gauge, sir.
Thank you. I am sure you have developed technical solutions. If there are more data which you would like to share along with amongst yourselves, please do so that these issues or concerns are suitably addressed. I see D1 has some query. D1, the floor is yours.
Yes, sir. Thank you, sir, for giving me the floor to intervene. So, sir, my question is, how will you stop the corrosion, because methanol is corrosive in nature and it can damage the fuel lines?
C1, you would like to respond to that?
Yes, sir. So methanol has low viscosity, but there are some methanol brine corrosion inhibitors that can avoid the corrosive problem. It is an organic compound like hydrogen sulfide, etc., which are completely soluble in methanol, which can eradicate the problem of corrosion.
Thank you, but hydrogen sulfide has got its other issue of being a very toxic, and at a it has a very low TEV for fatality in human beings. So please ensure that aspect of safety is covered when you talk of H2S.
Yes, sir, we will look into it.
Thank you. I see no further hands up on the floor. So thank you for information. Incidentally, you may also like to check with the design departments. Earlier, there were certain companies we were talking of collapsible containers to reduce the volume of empty containers moving around. I am not very sure whether technically that proceeded further, but that was one proposal which had moved forward, that could be looked at to like much more stacks of empty containers could be moved. But then that has got its related issue of the technology and the cost of the container itself behind that. But you may like to check up if there has been any development in that field along with your proposed suggestions. So thank you for your active participation on this topic, and I move on to Kolkata D2 and I invite them to take the floor.
Thank you, Honorable Chairperson, and a very good afternoon to one and all present here. We, Team D2 from IMI Greater Noida of the Kolkata zone, are here to present our paper on the inclusive GHG reduction in shipping for emerging economies. Today, the shipping industry accounts for 1,076 million tons, or 2.89% of the global GHG emissions annually, which is basically a rise of 9.6% or 99 million tons from 977 million tons in 2012. If this remains unchecked, the GHG emissions from shipping is projected to increase by a whopping 90 to 160% of the 2008 levels of emission. With the primary long-term methods of GHG mitigation, like the use of biofuel blends and alternate marine fuels like LNG, methanol, ammonia, and hydrogen, proving to be unignorable in the shipping industry's drive to decarbonization, it is also not a myth that these obvious instruments are cost-intensive and require major infrastructural developments. With us representing developing nations which have limited spending, infrastructural capabilities, and interest in shipbuilding, engine development, we were bound to present solutions which require a significantly lesser incurrence of cost while ensuring that IMO's decarbonization goals are met. Presented in this paper are two baseline solutions which promote the incentivization and training for GHG reduction and can potentially impact every stakeholder of the shipping industry. Number one is the introduction and implementation of a global carbon trading exchange scheme specifically for the shipping industry. We propose the introduction and implementation of a carbon emission trading scheme which shall put into use the existing tools and instruments developed and being used by the IMO, namely EDI, EXI, CII, and SEEMP. This will be mitigating the need for any amendments or development into the existing data collection, validation, and enforcement infrastructure. The scheme shall be executed in 2 stages, namely a preliminary and an operational level stage. While the participation in the scheme by the shipping companies shall be made mandatory, this would be allowing for the data collection for further research and improvement purposes. The one-time preliminary stage is further divided into 2 phases, where phase 1 deals with the data collection and validation, while phase 2 deals with the division and allocation of limits. For phase 1, the companies must provide the authorities of the scheme with the detailed data about every aspect of the vessel, of the entire fleet of that respective company. And these data points shall be stored securely in a server maintained by the authorities. After which, phase 2 comes into play, where we are using the required EDI for new vessels and EXI for existing vessels, which is calculated using a reference value and a dynamic reduction factor of usually 10%. Using this, a customized profile for every single vessel from every type of a ship in a company's fleet shall be created. This profile shall be used for providing every vessel of the company's fleet with a maximum permissible limit for CO2 emissions per nautical miles, which would be obviously correlating with the carbon intensity indicator or CII, which shall then be summed up, providing the company with an annual CO2 emission limit. This kicks off stage 2, which again comprises of 4 continuous phases. The first phase of stage 2 deals with the voyage-based calculation of carbon emissions, where vessels shall be monitored for carbon emissions in every single voyage undertaken, the data of which shall be stored securely and transparently in a portal, which shall be made available online for ensuring a continuous access of the same to the ship owners, who would be also provided with a dedicated dashboard to monitor each of their vessels' CO2 emissions. The second phase of stage 2 comprises of audits, which shall be carried out every year after the preparation of the final report of the CO2 emitted by the company as a whole from its entire fleet, executed either by the PSC based upon the MOU or any other accredited organizations representing the exchange authorities. The purpose of these audits are to verify the authenticity of the emission data which has been provided by the shipping companies throughout the year. After the completion of these 2 phases, the third phase of stage 2 comes into play, which deals with the allocation and requirement notification of carbon credits for companies, where the carbon credits are either allocated to eligible companies or a notification of the requirement to purchase the carbon credits are sent out to the companies which require the same. While in the final phase of stage 4 or stage 2, the allocated carbon credits are listed in the exchange and is then made available to purchase for the companies which have exhausted their allotted limits. The price of each carbon credit shall be determined based upon the market demand, which is again basic supply and demand. While some control can be exercised by IMO for regulating the purpose of regulating the cost of the carbon credit. Number 2, the second solution presented is the introduction of mandatory multi-level training and certification on environmental protection by GHG mitigation. For this, we conducted a survey among 126 candidates, which witnessed the participation of almost every stakeholder of the maritime industry. The participants were questioned if they have received any notable training for GHG reduction in shipping by their MTIs or company. To our astonishment, just 38.1% of 48 participants affirmed positively, while the remaining 61.9% or 78 participants mentioned that they have not been trained for GHG mitigation. The results which can be seen in the presentation on your screens. To elevate this incompetency on GHG reduction methodologies, we suggest the implementation of mandatory training for every stakeholder of the shipping industry. The suggested training shall be executed in 3 levels, namely the institute level, the company level, and the personal level. The institute level of training would be implemented during a cadet's pre-sea training, where we suggest the implementation in 2 parallel bands, which are, number 1, curriculum-based field-specific training, where the cadets from each department shall be trained with GHG mitigation methods which are relevant to their fields. And number 2 is the STCW-based standardized competency course, where the cadets shall be uniformly trained across courses and departments with practical, realistic, and standardized methods to reduce GHG on board ship. This shall then be included on the STCW course, which would be again following the corresponding norms. The parallel implementation of these bands, as you can see on your screens, shall pave way for the deployment of competent cadets in the shipping industry. Next up, the company level of training will be ensuring that the vessel-specific training or VST is provided to each and every personnel, which would be complementing the institute level of training. We suggest for the deployment of an in-house GHG mitigation department for every shipping company, which shall be responsible for the same. The shipping company must ensure that both their shore-based and ship-based employees are trained for GHG mitigation, while ship-based personnel shall be provided with their VST within 48 hours of onboarding every respective vessel, and the shore-based personnel should be provided with modules about GHG, its impact, and mitigation methods, which shall be specifically curated for the company. The third and the final level of training is the personal level, which serves to be a voluntary level of GHG mitigation training, which shall provide any seafarer from anywhere around the world with access to open source courses on GHG mitigation, which shall be made available online. So this finally brings us to the end of our presentation, where we would like to conclude that this paper deals with two root-level GHG mitigation methodologies, which when implemented parallelly can help with the following. Number one, creation of a mindset for GHG reduction among seafarers, employees, companies, ship owners. Number two, providing a realistic solution for the midterm and long-term GHG reduction for the shipping company industry through the minimal incurrence of cost, staying true to our category of D2. Number three is the incentivization for the reduction of carbon emission, where we are not levying any fines. Number four is the creation of a completely new market inside the shipping industry, which promotes GHG reduction, which also attracts investors. Number five is providing training to nearly every stakeholder of the shipping industry, thereby ensuring that only competent seafarers who are familiar with GHG mitigation methods are sailing in the high seas. Thank you, and we are now open for interventions by the esteemed delegates. Thank you.
Thank you very much, D2, for bringing in a different commercial aspect and a training aspect into the discussion, which I am sure the other delegations will appreciate. I open the floor for interventions. D1 Kolkata, the floor is yours.
Yes, sir. Thank you, sir, for giving me the floor to intervene. Sir, as my friend told, D2 Kolkata, that that there are two main levels. One is one at data collection level, and other is operational level. And while he is talking about developing countries, so I want to know that how, on the operational level, it will be good. It will be good for the economy for developing nation.
Okay, so your question is that can developing nations be forced to pay because of this issue?
Yes, sir, on
D2,
operational level.
D2, would you like to respond to that?
Yes, sir. It is a very rightly pointed point that on the operational level, but I believe that you're talking about the carbon emission trading scheme, and there are two levels. The second one is the operational level. So the operational level basically deals with the continuous phases which shall be implemented like every year. These are the continuous phases and not one-time levels, as opposed to the first point. So it is obviously very viable for developing nations for being a part of this scheme, because this requires negligible incurrence of cost and can be implemented readily within months. So we really believe that being a part of this scheme is feasible and a viable option for every stakeholder of the shipping industry.
Thank you. I possibly would elaborate a bit more on this in my closing comment, as definitely we would seek to get some data from you with your experience on how it translates into real numbers. But possibly I'll leave it for that for the conclusion. I see no further card on the table, so it is possibly that you have touched upon a topic which others require to possibly study a bit more in detail and familiarize themselves with. So I'll take this opportunity then now to put my question across to you. There is one which is the major trading where, like, one is ownership of the vessel, which is largely lying in the hands of developed nations. I'm looking now at developing and developed nations aspect, which was raised earlier in the question. And there is trade which is largely happening as, if I remember my figures from UNCTAD, about 60 to 65% in developing parts. So now that imbalance should not occur, that the cost of material because of a carbon trading scheme becomes higher for the consumers in developing countries, while the benefits of the same are enjoyed by the owners in the developed countries by getting funds to modernize their ships. That would be an imbalance as far as developing countries would consider under the common but differentiated mechanism for contributing towards environment change. So while the concept of yours towards exchange is well noted, how will it equate into equitable distribution of the cost so that the developing countries don't land up paying for the already pollution done by the developed countries and thereby further impact their development goals, is something which possibly you would have to look in detail when you take your proposal further, and we would look forward to that. So I have not used this opportunity of a bit of time to put my thoughts on the table, and that would be the concern of developing countries. And I'm sure if you were to look at developing countries' papers on market-based measures, this is the flavor you would find at MEPC. And you would like to respond to that, D2? The floor is yours.
Thank you, sir. You have really touched upon a very sensitive and important topic and an important aspect of our paper. That the point which you raised is very realistic. And for this purpose, we have initiated the audits, which would be ensuring that the data which are presented and the data which are shown to ship owners and the shipping company is verified by the port state controlled or any other accredited authorities. And the final point of our presentation also emphasizes on the fact that the price of each carbon credits would be based upon a proper demand and supply model, which is being used at any other exchange. And we have also mentioned that IMO shall have the power to regulate the prices if necessary. So I believe that would be somewhat regulating the price and curb this issue of imbalance. And this obviously requires further research and further implementation. So we would definitely look into it.
Thank you. And raising the training point, of course, I don't think there are any interventions on that. It's absolutely something which can be easily done and would add value. Thank you very much. And now I call upon the last participant in this session, Kolkata E1, to take the floor and bring forward their presentation. Kolkata E1, you are there? Even are you having some difficulty in sharing your presentation?
Yes, sir. Sir, we need just a few minutes.
I think she should go to slide down below right side.
Yes, there you are.
I think it's okay. We can see this way sliding down, or you can go back to original shape. No problem. It is visible.
Kolkata even, is there some technical issue because of which you're not starting?
Yes, sir.
Okay, can you explain what is your problem? And maybe we can help you out.
I think one slide they are not going to show off. They can show later on, no problem.
Excuse me, sir. So we would like to start with our presentation.
Please go ahead.
Good afternoon, respectable chairperson, sir, and co-chairperson, sir, honorable judges and earnest delegates. I, Cadet Sushnata Mukherjee, along with my delegates of category E1 Kolkata zone, are going to present our PowerPoint presentation on study of sustainable methods for reducing GHG emissions by implementation of hydrogen fuel cells. Here we have divided the entire presentation into various parts. First, the main goal of our paper has been discussed. After that, we have dealt with why one should prefer hydrogen over other biofuels and how it has become highly advantageous in the maritime sector. Electric propulsion system, its trend going through the years globally, and the paramount focus of our paper, which is working of hydrogen fuel cells, its advantages, disadvantages, solutions, and challenges, has been discussed thoroughly in these slides. Lastly, we have concluded with the idea of how fuel cells have been used all over the world. So, what is the main objective of our paper? The shipping sector is the backbone of international trade and global economy, accounting for around 90% of global trade. Even though it is the least contributor to marine pollution, it is one of the largest carbon emitting sectors, accounting for 2 to 3% of the global greenhouse gas emissions. In order to improve the overall efficiency and also reduce the carbon footprints, our paper focuses on using an alternative propulsion system, which is the electric propulsion system, where the generator is powered by hydrogen fuel cells. Here from the pie chart, it is clear that hydrogen can be considered as the best alternative of heavy fuel oil or heavy diesel oil, which are generally used in ships. The various numbers indicated in this chart are the life cycle GHG equivalents for different fuels, which are measured using the well-to-propeller and field-to-propeller methods. Now the question arises, what makes hydrogen superior? Some of the properties which govern its excellence are it is a cryogenic liquid and compressed gas which emits zero carbon dioxide when used in fuel cells converter of hydrogen. It has also been considered for its potential for storage of excessive renewable energy from hard to control sources such as wind or solar. When consumed in dual fuel consumption engine, hydrogen can significantly reduce carbon emissions. The ship's electric propulsion system method has been discussed in this slide, along with why we should choose electric propulsion over other propulsion systems and what are the global trends related to its utilization. Electric propulsion system reduces the overall weight of the mechanical equipment, increased tank capacity, and improved navigation energy. Usage of high-speed, non-reversible thermal energy improves flexibility of choice. The prime mover can use the high-speed, non-reversible thermal energy to improve the flexibility of choice, and along with that, good combustion of hydrogen fuel cells, saving fuel and reduces emissions. The ship's electric propulsion system is driven by the prime mover to generate the generator, and the electrical energy is supplied to the propulsion motor by the frequency converter. And the propeller is driven by the propulsion motor to push the ship forward. The graph gives a small glimpse of how this kind of technology is being used through the years. Electric propulsion system, which was once discovered in the 1910s and was disregarded till 1980s, has again got the attention it deserves in the 21st century. It is believed that soon almost 90% of the ships will be propelled using this method. Now I would like to hand over the presentation to Cadet Khushi Agarwal.
Thank you. So now taking over, the electric propulsion can also be done using hydrogen fuel cells as the main source of energy. So how do hydrogen fuel cells work? It consists of two electrodes, anode and cathode, and an electrolyte between them. Hydrogen is fed to the anode, while oxygen is fed to the cathode. At anode, platinum catalyst splits the hydrogen into electrons and protons. Since only the protons are allowed to pass through the electrolyte, the electrons must flow along an external circuit to the cathode, creating an electrical current. At cathode, electrons and protons combine with oxygen to water as byproduct. Now, moving on to next slide, pros and cons of hydrogen fuel cells. Pros. It is emission-free. Hydrogen is available in infinite quantities. It is high range. It gives high range to the propulsion of ship up to 600 kilometers. It can be refueled. It gives lower efficiency due to high energy losses. Second, highly flammable. However, hydrogen volatiles rapidly. Poor infrastructure, only 60 filling stations in Germany. High cost, very expensive to purchase and maintain. Moving on to next slide, I would like to hand over to my fellow mate.
This table is a clear interpretation of all the challenges we are going to face with regard to the installation of hydrogen fuel cells in ships and the research areas we need to focus in order to completely eradicate these problems. The first drawback of this system, as shown in the table, is the installation on board ship. Now it depends on the ship's reliability, stability, hybrid energy management system, and storage. Optimum vessel routes can be used for this purpose. The trouble about hydrogen storage is been thoroughly discussed in the next slide. Now the major difficulty of the system is the exorbitant cost of hydrogen energy conversion mechanisms through fuel cells and the lack of logistics and transport infrastructure. Mass production of fuel cells will of course solve this problem, but when we look for a permanent solution, the cost of making these fuel cells are high because of the use of platinum as a catalyst. Researchers have developed a hydrogen fuel cell that uses iron, carbon, and nitrogen materials that are cheap and readily available instead of rare, costly platinum, enabling greater use of the technology. Now I would like to hand over the next slide to Cadet Khushi Agarwal.
So, moving on, the solutions of the problem which we have analyzed are as follows. Flammability of hydrogen can be taken care by using less or more of it than 4 to 75%. Reducing cost of hydrogen fuel cell by mass production of the fuel cell and using platinum-free hydrogen fuel cell. Methods of storage of hydrogen can be carbon dioxide based methanol or ammonia based. Moving on to next slide. In the past few years, various fuel cell ship projects took place in different countries, which are as given in this table. These projects which will be helping us turn this theory paper into reality all over the world. Now concluding our research, I would like to say All the various researches have been conducted in underdeveloped countries. These countries must establish clear strategy and goals, improve the research on regulation and norms, make breakthrough in first hydrogen fuel cell, take marine technology, second marine high safety. As said by great Thomas Edison, the value of an idea lies in the using of it. Now I would like to add one more point. With an ongoing push by the maritime community to reduce ship emissions to satisfy IMO MARPOL Annexure 6 regulations and limit the sulfur content of ships from 1st January 2020 to 0.5% worldwide, many ship owners are starting to consider hydrogen fuel cell technology to satisfy evolving emission regulations. Thank you for your kind attention, and now we are open to questions.
Thank you, Evan. And I see the hand of D2 is up. D2, you have the floor.
Thank you, sir, for providing us with the floor. First of all, congratulations to Ivan Kolkata for coming up with such an insightful presentation. While we cannot disagree with the fact that hydrogen is definitely a marine fuel of the future, we would love to hear your elaboration on the fact that how exactly do you wish to produce the hydrogen? Because we would love to draw your attention to the fact that more than 90% of hydrogen which is currently produced for use as a fuel is produced through the reforming processes of fossil fuel. We would thus seek further clarification on the same, and also we would love to provide you with a suggestion of ours on the fact that you could actually use the membraneless electrolysis technology for the production of hydrogen as a marine fuel, because this is comparatively a new technology and it results in a very sustainable production of the same, while it was originally developed for the shipping industry for use as a method of ballast water purification system. So thank you and congratulations.
Thank you, D2. Would you like to respond to that, Evan?
Yes, sir. Thank you for a suggestion and we will look into it. Like in here, we are like hydrogen can be produced in fuel cells, and there are various types of fuel cells we can use, like proton exchange membrane fuel cell or high temperature fuel cell. But here we are using the electrolysis method. Hydrogen can be also produced through wind power or solar. But in electrolysis method, the main focus of our paper should be like reducing carbon dioxide completely, and by using this method only the byproducts produced are water vapor and heat. So we want to use this method.
Okay, thank you for the clarification. And I have D1 requesting for the floor. D1, go ahead.
Yes, sir. So I would like to ask that how will this means hydrogen storage tanks with high weight and volume will be implemented on ships? Would like to hear from that.
So carrying of hydrogen as fuel on board, how is that supposed to be handled is, I think, the query. Evan, would you like to respond to that?
Yes, sir. Sir, the main problem of producing hydrogen, like carrying it, is the storage methods. So we have compared all the storage methods, and we have seen that not only hydrogen but any other alternative fuels, the energy densities both by weight and volume of diesel can never outreach diesel fuels. So by switching the fuel type will always increase the required weight and volume on board a ship. But this could be also seen as a disadvantage, as there are two main factors in marine shipping industry to counter the negative effects of increased storage volume. Firstly, the ship usually have a fuel on board that is required for the chartered voyage, and also secondly, for large ongoing seagoing vessels in the range of 100, the fuel tank can only take up to 1 to 2% of the total ship weight. So even if an increased fuel capacity is needed when sailing on hydrogen for long voyages, the total extra weight that the fuel tank will take up should not be too extensive. Moreover, to decrease the weight and volume as much possible, volume exchange tanks are also being used.
Okay. A2, you would like the floor?
Sure.
A2, go ahead.
Yeah. Thank you, Chair, for providing me the floor. My question is to even MEPC Kolkata is that how do you plan to reduce the exorbitant cost of hydrogen fuel cell, because mass production can never be enough to solve this problem?
Would you like to respond to that, Ivan?
Yes, sir. So the main problem of hydrogen fuel cell is that is because of the use of platinum as a catalyst, and researchers have already found the method to combat this by using iron, nitrogen, and carbon. Here, the iron is dispersed as a single atom in an electrically conducting carbon matrix, and its properties are also similar to that of platinum. So we are planning to use it.
Okay, so that should bring your cost down.
Yes, sir.
C1, the floor is yours.
Thank you, Chairperson, sir. My concern is, like, as we know that fuel cell having high efficiency, but instead of that, we know that it has a high efficiency, but then also we have to understand that it also consumes, it also have a higher volumetric size, and how we can implement it in developing countries on ground, how we can make
So,
it in effect.
so you are also concerned about the commercial impact of the space utilized for such a plant.
Yes, yes, sir. Yes, sir.
Okay, thank you, C1. Ivan, would you like to respond?
Yes, sir. The space utilization would be related to onboard because the entire process is carried on ship, the production, storage, volume, everything. And as the questions was also asked by another team regarding the storage and volume, we have already mentioned that we can use storage exchange tanks for its storage, and uh, also use also use large seagoing vessels because it can be an alternative method. So that's it. And
Okay.
another point I would like to add is, like, hydrogen fuel cell is less efficient, as it has been mentioned, but we can also use hydrogen for other purposes on board, like for combustion engines and gas turbines.
So use a hydrogen as a direct injection as a fuel instead of
Yes,
a
sir.
fuel cell.
Yes, sir.
Okay. Thank you, Ivan. And I see no further cards. Uh, I think I took the advantage of the small break in between to put some thoughts on paper so I can try and summarize so that you can have uninterrupted lunch without me having a small break. So I'll try to conclude this session now. First of all, thank you participants for your interactive participation, sharing your ideas, bringing about technologies. We heard Kolkata A2 share with us a lot of information about all the possibilities which exist for the maritime field. And considering their advanced work in all of them, we look forward to their further submissions with details on these so that they can be shared with other member states and people could look at options which suit their system the best. Kolkata C1 touched upon a topic of how a lot of energy is going on in transporting empty containers, and if that could be trimmed down, it would lead to a lot of solution. We look forward to your continued work on that, and giving, if you do some experiments or do some studies to share that, we could share that across member states so that people could follow the models, and something which is being fuel is being burnt to just place the containers in places. If that could be utilized more effectively, definitely it will go towards reducing the overall fuel consumption of the maritime sector. You C1 also talked about alternative fuels on methanol fuel cells. We look forward to your further research on that, and as you develop that into from experiment into real projects, if you could keep sharing the information, it would be very helpful. D1 brought us to biodiesel, though their present usage is based on palm oil. They showed us also how much more options are available across the world internationally. and we look forward to getting more information from you as how that could be, if not the final zero carbon fuel, but at least intermediate fuel which for transition the world could look at for reducing greenhouse gas emissions. D2, I did dwell upon that paper a bit, did bring about a new aspect of commercial incentive to make people go for reducing their greenhouse gas emissions, which is another approach. As they work further on that, if they do for some further research, we look forward to more detailed papers from them. And of course, on the training aspect, it would be very useful if they could continue sharing their views on that so that that aspect can also get covered. Finally, we had E1 share with us their views on hydrogen fuel cells and how they plan to not only address the issue of the cost of hydrogen fuel cells, but also certain solutions they can give regarding transportation of the fuel or alternative methodologies of uses of hydrogen as a fuel. As they have highlighted certain projects which are already ongoing, we look forward to the progress of the projects or any other new projects that are undertaken to enable members to get educated about the same, enabled national and also further assist in international policies on alternative fuels. With that, my summarization of the session is over. If I have any comments from the judges, I would like to take. Else, we will bring of the MC.
No, negative from my side at the moment.
Right, sir. I see no. I see nothing further from Mr. Ramamurthy, Mr. Datta, or Mr. Mehrotra. Okay, so Ramamurthy, sir. Yes, sir. Sir, you are on mute, sir.
I just want to inform the delegates there are many incorrect, figures and statements given on them. I don't want to go into many details of it, but I could find many of them. So they have to get into that and see that all these are in a proper way. Another point is presentation has been made to the point. They were just going away from the points in many of them. And this is something I noticed. This is a general observation from me. Thank you.
Thank you, sir. So I hope all the delegates are taking note of these observations. And as I said before, here you are getting an opportunity to present. In IMO, it is only your paper and your introduction of the paper. So that is why the focus is mostly very important to have your paper in a very, very good readable format, which people appreciate, and your introduction is able to cover it. Dr. Saxena, sir?
Yeah, thank you. Thank you. Something which I had mentioned that day in the meeting also. See, submission in IMO is a very crystal clear, to the point submission. Okay, it is not a technical paper presentation. Okay, so there has to be a very clear difference because here we seem to be having little more emphasis on how you present a technical paper. That is not the objective there, you see. I'm not just talking about the presentation, even the text which when you speak. Okay, it has to be really focused to what you really want to present. Not, you're not developing a technical paper and, the history of that or how does that so-and-so thing works and all that. That's not required there, at that level. Thank you. That's all I think at the moment I can say.
Thank you, sir. And I'm sure the delegates are listening to this. So we have a 1 hour lunch break. We will get back at 1:45. Is Gaurav my table correct?
Shall we start at 13:30? 45-minute lunch break?
Let us keep it 13:45, the published schedule. I don't want suddenly finding that people have made some program and are not able to join in time.
Okay.
So we keep it a 1 hour break.
Okay, 1 hour break. We'll assemble at 13:40.
13:40, so that we can start at 13:45 sharp.
13:40. Thank you.
Thank you, sir. Thank you.
Thank you, everybody.
Kolkata campus. The Indian Maritime University, Kolkata campus comprises two premier institutions, the Marine Engineering and Research Institute, MARI, Kolkata, and the Indian Institute of Port Management, IIPM, Kolkata. After 63 years since its inception, MARI is regarded as the most acclaimed institute around the world for maritime education. In IMU Kolkata campus, we offers B.Tech in Marine Engineering, M.Tech in Marine Engineering and Management, MBA in International Transportation and Logistics Management, Navi Mumbai Campus. Indian Maritime University, Navi Mumbai Campus was formerly known as the Traineeship Chanakya. This campus came under Indian Maritime University in 2017. It was named as Navi Mumbai Campus. In IMU Navi Mumbai Campus we offers BSc Nautical Science, 1-year diploma in Nautical Science, DNS, MSc in Commercial Shipping and Logistics, Advanced Firefighting Course, GMDSS course. Mumbai Port Campus. IMU Mumbai Port Campus is consisting of two premier maritime institutes of India, the LBSCAMSAR College of Advanced
क्या हो रहा है? Good one.
I didn't realize the mic was on. Small nap.
Yes, we are used to that.
That is the problem of post-COVID now. You have to be very careful of these.
Gaurav, in that IMU Kolkata movie part, why they didn't say the DMT? You know, they said Mary, but you know.
They should actually.
Yeah, DMT they should.
But they were for the surprise. It is the original DMT.
Yeah, they should.
I will put it out. Good idea.
They said that.
First 4 years DMT couldn't come there.
Yeah.
Right.
Right, sir. I think 1, 2, 3. Mr. Datta is there?
No, he's still.
I'm there. Thank you.
Yes.
So,
Yeah, he's looking handsome there in that photograph.
I just introduced the team for the third session today. Welcome everyone. After the invigorating lunch break, to the third session of MEPC semi-finals. The 5 qualified teams which form the MEPC Group 3 in session 3 are the C3 and the D2 teams of Chennai zone, the E4, Eco 4 team of Kochi zone, and the Bravo 1 team of Kolkata zone. The Kolkata zone guide, Mr. Sanatani, has already been introduced. The Chennai zone guide for MEPC, Mr. Mahesh Subramanian, has already been introduced. The Kochi zone guide for MEPC is Mr. Devu Kavi. Mr. Kavi has stayed on various types of ships, like oil tankers, bulk carriers, container ships, to the rank of chief engineer. He is presently the senior principal surveyor and vice president at the Indian Register of Shipping, heading its machinery department as well as the shipbuilding project department. He is also part of the MEPC committee at DG Shipping, member of the ballast water review group, as well as member of the air pollution review correspondent group at IMO. I now hand over to the session chairman, Mr. Rajiv Nayyar, to take the proceedings further. Rajiv, over to you.
Thank you, Gaurav, and good afternoon to all the delegates. We now start session 3 of the day. We have 4 teams in this session and 5 in the last session. So I will invite Kolkata B1 now to take the floor and introduce their paper. Kolkata B1, are you there? Okay, thank you.
Yes.
A very warm greeting of the day to the Honorable Chairperson, the jury, the delegates of the member states, and the audience of the event. I, Cadet Momini Sarkar, along with Cadet Josh Mehta, Cadet Samit Das, and Cadet Saidi Datta, are the delegates of Team P1 IMO Corporate Campus. We are honored to present for you our proposals and suggestions on ways to reduce GHG emissions from ships and the maritime industry as the representatives of the future workforce. Shipping, being the most carbon efficient mode of transport, is the backbone of the global trade, carrying around 80% trade by volume. Despite this, the industry stands as a potential threat to the environment. According to the fourth IMO GHG study, global shipping emitted 1056 million tons of CO2 in 2018, accounting for about 2.89% of the total global CO2 emissions. From 1990 to 2019, the global warming effect from greenhouse gases surged by 45%. IMO believes that emissions from shipping could represent 17% of total annual CO2 emissions by 2050. And despite such alarming evidence, the maritime industry was excluded from the Paris Agreement. Widely used since 1960s, the biggest culprit behind the GHG emissions from shipping is heavy fuel oil. Today, it is popularly used by 60% of the approximately 60,000 ocean-bound large vessels in the world, since it's cheaper by 30% than the alternatives. HFO contributes to climate change through emissions of black carbon, accounting for 21% of CO2 equivalent emissions from ships, making it the second most important driver of shipping's climate impacts after CO2. It is also highly concentrated in sulfur, about 35,000 ppm, accounting for 8% of sulfur dioxide emissions globally, along with nitrogen oxide as a byproduct. IMO has been introducing policies like EEDI, SEEMP in order to regulate carbon intensity of marine fuels. The initial strategy adopted by IMO in 2018 envisions reducing the total annual GHG emissions from shipping by at least 50% by 2050 compared to 2008.
In order to achieve the ambitious yet critical targets, it can be agreed that transition from conventional bunker to cleaner alternative fuels is the most feasible policy liable to be implemented at this stage. The various potential alternative fuels are hydrogen, methanol, ammonia, and LNG. Methanol is advantageous over some alternative fuels since it is a liquid that is stored, transported, and used at ambient temperature. Implementing it as a shipping fuel would be more straightforward than switching to cryogenic LNG or gaseous fuels such as hydrogen. But hydrogen is often touted as a clean fuel because water is its only combustion product. Therefore, making liquid hydrogen a top choice for substantially cutting carbon emissions. But the fuel needs to be produced renewably and not from fossil fuels. Ammonia is a potential candidate as zero carbon fuel. There being no carbon atom in the ammonia molecule, it does not emit carbon dioxide during combustion. Ammonia has an energy density similar to methanol and more favorable than hydrogen as it requires less cooling than cryogenic liquid hydrogen. But as seen in the figure presented, the suggested fuels lag behind LNG on key indicative barriers like availability, infrastructure, technical maturity, safety and capital expenditures for substituting the conventional bunker.
LNG carries the potential to reduce SOx emissions by 99%, NOx emissions by up to 95% for diesel cycle engines and up to 85% for Otto cycle, and CO2 emissions by as much as 20%. It produces 99% lesser particulate matter. LNG fuel vessels can reduce their EEDI rating by 20%, while their carbon intensity indicator will be reduced by approximately the same amount. In addition, its proven reserves surpass that of oil, and its ability to provide a stable long-term supply for more than 50 years is a key advantage. LNG can reduce GHG emissions by up to 27% over entire life cycle, and therefore LNG is our safest bet as a fuel for transition to achieve GHG emissions target set by IMO against backdrop of tight deadlines until zero carbon fuels like hydrogen and ammonia become viable for large-scale commercial use. Globally, the number of LNG-fueled vessels has increased from 18 completed vessels in 2010 to 175 currently in service. They also amount to approximately 13% of the current new build order book.
A significant drawback of using LNG as a maritime fuel is methane slip, which is the discharge of unburned methane from an engine. Methane slip can potentially eliminate the gains that LNG may be able to offer as an alternative fuel. The small yet significant volumes of methane released have 25 to 30 times the greenhouse gas effect of carbon dioxide. The phenomenon is most prevalent on gas burning engines operating according to the auto combustion process, where gas, fuel, and air are mixed homogeneously prior to ignition and combustion. Hence, it is crucial that we tackle methane slip in order to retain LNG as a choice for transition. IMO had also declared in 2019 the aim to produce concrete proposals to reduce methane slip and emissions of volatile organic compounds. And in pursuit to achieve the following goal, we put forward our proposals. We propose regulation for new ships to install engines upgraded to run on diesel cycle or dual cycle and stop using engines with auto cycle since they produce a higher methane slip. Methane slip in Otto cycle occurs mainly due to two reasons. First, being methane getting caught in dead volume spaces within the engine, and second, incomplete combustion of methane. Therefore, the older ships using engines running on an Otto cycle should ensure that upgradations are made in order to achieve first, direct gas injection, reduction in crevices volume of combustion chamber, and an increased overlapping of inlet exhaust valves and gas admission time. It is also proposed that such engines be started after treatment with oxidation catalysts, which is said to reduce methane slip by more than 10% according to several studies. Furthermore, we believe that regulations focusing on methane emissions should be introduced just like those on NOx and SOx emissions.
Just like addition of GHG emissions into the atmosphere surges global warming effect, the removal of carbon dioxide will aid in preventing this effect. Carbon sinks refer to sites which absorb CO2 from atmosphere and ocean acts as a large carbon sink. Therefore, to stimulate and assist this phenomena, we propose establishment of government-assisted authorities at various governance levels to promote maintenance and promotion of vegetation under ocean waters and along shorelines. We also suggest the addition of marine carbon sink to sustainability criteria for marine fuels in the form of a consideration in the fuel life cycle label. If not in the process, then at least as a point of reference for standardizing the FLIP, that is, the fuel life cycle label. Our proposals focus on reducing the GHG emissions from vessels and abating the hazardous effects caused by it in the most practical way. The discussed proposals are well-rounded and therefore we urge for support and effective implementation by all member states to yield significant results and large-scale impacts. Hence, we invite all members and stakeholders to put forward their valuable opinion and necessary amendments to the above-mentioned proposals and urge the committee to adopt them to salvage our vulnerable global climate from the threat of GHG emissions. Thank you, Chairperson, sir. We are open to interventions now.
Thank you, Kolkata B1, bringing into technical measures which can be used to take care of methane slip and also carbon capture, how to address it. Thank you for bringing these points to the table. I open the floor to other delegations now, if they would like to intervene. I see so far no cards upon the table. I hope the rest of the member states are already in the hall already. Considering these suggestions which you have made, has there been any development in your member state regarding this carbon capture and any data you could possibly, if anything has been done, share in future sessions regarding how certain underwater uh, plants and all could be developed and assist in absorbing carbon dioxide, any way of measuring this? Would you be able to do that? Would you like to answer that, Kolkata V1?
Yes, sir. For a proposal on marine carbon sink, the ocean carbon sink has been estimated from the global ocean biochemical model since the start of global carbon budget activities. They have set up uh, models on ocean anthropogenic carbon sink for 1990s, and this has the calculations of the calculations and parameters on which these models have been set up have been changing from time to time, and some of them have been found arbitrary. But according to recent studies, when they have changed the parameters, we are finding significant improvement, and we believe that ocean can act as one of the biggest marine carbon sink after there have been improvements and corrections in the calculations that have been made. Yes, sir.
At the Secretariat, once you have information, you could share it and we could disseminate that information. It would be helpful for other member states. On the same lines, when you are asking for modification of engines, has any modifications been done in vessels in your member state ownerships, whether technically feasible or does it involve full changes of engines? If you could get data on that and share it if you don't have it presently in future sessions, it would be helpful. Meanwhile, I do see the card of E4 up. E4, you have the floor.
Thank you for the opportunity, sir. And good afternoon, everyone present over here. Our paper do share the same core in the proposal and do like to collaborate with this. The project certainly do have a greater potential for a developed country, and since it do comply with the national standards, it seems great. Thank you.
Thank you, E4. I see no further comments, so I will invite.
Excuse me, sir.
Yes,
sir. On behalf of B1, I would also, as you asked for some recent development for the
Okay.
engine.
Yes, please go ahead.
Yes, so there is a recent development by the engine specialist WinGD. They are working on intelligent control by exhaust recycling, that is ICER, which is a new technology which decirculates the methane to reduce the amount that is left in the exhaust system and ultimately escapes into the atmosphere. So this is the most recent work on this project, sir.
Thank you for that information, and for future sessions, if you could get further details and submit it for information of member states, such a research would be helpful in working on this issue at the earliest.
Yes, sir.
Thank you very much. I now invite Chennai C3 to take the floor.
Good afternoon, sir. I hope the presentation is visible and I'm audible, sir.
Good afternoon, and yes, visible. Please go ahead.
Thank you very much, sir. A very good afternoon to one and all. I am V. Tirumala Vedaditya, speaking on behalf of my team C3. Our topic for today is to introduce methanol as a new regulatory fuel. Now, we would like to give a brief introduction on how methanol is effective in reduction of GHG emissions. Greenhouse gas is a compound in the atmosphere that is capable of absorbing infrared radiation. By increasing the heat in the atmosphere, greenhouse gases are responsible for the greenhouse effect, which ultimately leads to global warming. Here, we have depicted the GHG emissions in a year-wise data in form of a pie chart and a bar graph. The pie chart shows the global GHG emissions from different kinds of ships. It is evident that the majority of the emissions are from container vessels, which is nearly 23%. The bar graph shows CO2 emissions in million metric tons during the years 2011 and 2011 to 2015. According to IMO, there should be a cut of annual greenhouse gases emissions as an average across international shipping by at least 40% by the year 2030 and 70% by the year 2050 compared to the studies in the year 2008. Now, we'll get to the main concern. Why is GHG emissions from ships that is important? Our main concern of GHG emissions from ship is because roughly 90% of the world's goods are transported by sea, with over 70% as containerized cargo, and nearly 11 billion tons of goods are transported by ship each year. So our main aim will be to reduce GHG emissions to avoid the most catastrophic impacts on the environment. There are various methods to reduce GHG emissions coming from the ship. Some of them are battery powered, solar powered, and alternative fuels. So we thought of the best feasible solution from the use of alternate fuel, which is methanol. Why methanol as a fuel? There are certain reasons to consider methanol as an alternate fuel. It is cost effective, can be found globally. The raw material used for synthesis of methanol is CO2, which is being extracted from the atmosphere, and hydrogen gas, which can be collected using electrolysis. Combustion of methanol produces nearly 90% less carbon content and 80% less NOx emissions. And obviously, complying with the present IMO regulations, nearly 0% SOx emissions. The result itself shows the positive outcome of usage of methanol as a new regulatory marine fuel. There is no need to build separate storage and bunkering facilities for methanol, as with some minor modification to current fuel storage and bunkering facilities, we would be able to store methanol efficiently. While combustion also, there is no residue left. Now, coming to the methodology of the production of methanol. The synthesis of methanol is done from the greenhouse gas CO2 and H2, which is a promising strategy. Firstly, the atmospheric CO2 is captured using mechanical process, and then it is synthesized with the help of H2 using copper or palladium multi-component catalyst. We will be getting synthesized methanol, which can be further used as ship fuels. Here, the following flowchart shows the cycle from production to end results. This chart is similar to the methodology where CO2 and hydrogen are used as raw materials and then synthesized with copper and zinc oxide or palladium copper catalyst in production plants. Then we will achieve synthesized methanol. Further, it is transferred to ships, which will be used as fuel oil. After the combustion takes place in the engine, very less NOx emissions and CO2 emissions are given out, and 0% SOx emissions. Next, we'll come to the advantages of using methanol as a fuel oil. One of the most aspects of the methanol is that it is soluble in water. Hence, in any case of accident or oil spillage, it will be soluble in water. Methanol is subject to some same bunkering guidelines and safety standards as most conventional marine fuels. So, with just minor modifications, we can easily bunkerage methanol. Other advantages lie in properties of methanol. It is liquid in ambient conditions, as in room temperature conditions. The handling on board a vessel is therefore much easier compared to gaseous fuels. Furthermore, methanol is less hazardous for aquatic organisms compared to well-known marine fuels like gas oil or heavy fuel oils. Carbon dioxide is the major cause of global warming. By removing carbon dioxide from industrial emissions and using it as one of our main raw material, our proposal stands out among others, which will definitely play a key role in sustainable development. Here, we'll take a look at scopes and limitations of using methanol as a fuel. The techno-economic analysis of this process of capturing CO2 is considered a bit costly, but looking into the present situation and thinking about the further generations and to make a sustainable development in this industry, this process can be considered viable. Methanol burns at lower temperatures than gasoline, and both are less volatile, making the engine starting in cold weather more difficult. Methanol, like ethanol, contains soluble and insoluble contaminants, which contains halide and chloride ions. These ions may cause corrosion in fuel tanks and pipes. Methanol is hygroscopic in nature, meaning it will absorb water vapor directly from the atmosphere because absorbed water dilutes the fuel value of the methanol and may cause phase separation, methanol and gasoline blends. Containers of methanol should be kept tightly sealed. Now we'll get to the implication and recommendations of the we would like to suggest. Though our country is considered to be a developing nation and having moderate level of interest or ambition in reducing carbon dioxide emissions, it is much interested in giving a large spending on capabilities of infrastructures. There needs to be studies and findings that are to be made for methanol related research where it can be considered as a major bunkered fuel. recommendations for encouraging the uptake of e-methanol as a green fuel alternative and create industry standards for safety. In conclusion, we would like to say that our team like to say that considering methanol as a new regulatory marine fuel can be a viable and sustainable solution, which in turn will help us improve the environment. And obviously, there should be engines that are to be provided which can run as a fuel oil. As we have mentioned, some minor changes are to be made to the existing engines, which can be done using less capital cost. A cleaner burning fuel, methanol, can help improve local air quality by reducing emissions, complying to the goal of cutting 70% of greenhouse gas emissions by the year 2050. We would like to say that our solution can be considered one of the best options where methanol can also help society achieve its decarbonization goals. Thank you, sir. Now we've come to an end of our presentation. We would like to take any questions and interventions from my fellow delegates and panel members. If any agreements or disagreements, we will really be glad to respond to them. Thank you.
Thank you, Chennai C3, for introducing methanol as a viable future for marine field. I open the floor for interventions. B1, B1 Kolkata, the floor is yours.
Thank you, Chairperson, sir. We agree with the potential of green methanol and e-methanol as an alternative fuel, but the green methanol industry is currently small and therefore there are only a handful of commercial producers worldwide. Consequently, green methanol costs significantly more than alternative fuels that are proposed, according to a report from the American Bureau of Shipping. Hence, how should we drive capital investment for methanol rather than LNG with better prospects and fast-growing infrastructure as an alternative fuel?
I would like to say that methanol is a very better option in considering as a fuel, but the capital investment and the options available to us are really narrow. I would suggest that countries should be collaborating with one another, or proper implementations are to be made so that uh, knowledge will be provided to everyone. Thus, the capital investment and providing a good amount of research in this will be advantageous to methanol as a new fuel oil. Thank you.
Thank you, C3, for the clarification in response to the query of Kolkata B1. Kochi E4, you would like to take the floor?
Thank you for the opportunity, sir. The proposal seems valid to a certain extent to us, to be frank, considering the emission criteria of ship from section 14 and 16 of the paper. But the ideas to dodge the challenges such as the lack of dedicated infrastructure, corrosiveness and toxicity is still unclear. Although the emissions are safer than that of gasoline fuels, methanol surely has a significant amount of formaldehyde emission, which has an adverse effect such as sense damages to all organisms. Plus, it is even being carcinogenic. The fact that the ship owners consider running cost of the ship as in the top line, with them struggling at the time of low sulfur content oil shift in 2020, we think it is important to remind that methanol is expensive than that of gasoline. We certainly do understand that the growing technology might help with the current issues, but we like to know how the team actually proposed to dodge these and would like to collaborate with them. Thank you.
Thank you, E4 Kochi. Chennai, we would like to respond, Chennai C3?
Yes, sir. We definitely do. Thank you for the question, Team EFO. The point comes where we need to choose, are we investing in the capital, or are we going for higher emissions fuels? So there definitely needs to be a viable solution to invest in methanol, even though it's a costly process. The capture of carbon dioxide is a bit costly, and the rest of the process will be easier and cost-effective process. So yeah, that's what I think about it.
Thank you, C3, for that clarification. D2 Chennai, please take the floor.
Good afternoon, sir. Hello, Team C3. That was a nice presentation. Actually, I have a small doubt. Like in developing nations, as you said, maybe the economic cost of this methanol production may be high, but the effect is also high. So, do you think in like real time, is there any developing nation that is ready to invest in this?
Yeah, I think yes, there are some nations which are readily interested in investing the usage of methanol. I cannot recall the nations which are presently, but there are few nations which are regularly running ships in methanol-based fuels. So yes, there is definitely a scope for usage of methanol as a fuel oil and production of it.
Thank you, brother.
Maybe in future you could share information about where experiments have already been done or trials are on, and that would also help members know about what things are to be done on the engines to make them suitable for methanol running. I see the card of C3 Chennai again up. You have another.
Yes, sir. Like I would like to, if it's legible to state, I mean, I would like to cite a paper from previous group, Kolkata C1 group, which is decommissioning of container cargos. I mean, we have already stated that just a minute, sir. As over 70% of trade is taken by containerized cargo, they have suggested decommissioning of empty container tanks, and they've also suggested methanol as an alternative. So we would like to really collaborate and share some ideas and thoughts with them. It will be definitely a really good opportunity to enhance the development and reducing of these GHG emissions.
Yes, I think that of the technology
Yes,
of
yes.
methanol
Yes,
fuel
yes.
cells. Like,
Yes, 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 sir.
yes, I'm sure you can find the contacts and get in touch and do further collaboration. Thank you. With that, I now request Chennai D2 to take the floor and introduce their paper.
Sure, sir. Thank you. Good afternoon, sir. Good afternoon to all the respected dignitaries and my dear friends and viewers. So we are from D2 team IMU Chennai. So our topic is mainly about onshore power supply. So introducing this topic, there are two contexts that I want to touch upon, which are in the context of developing nations, as that is what I tested to us, and other thing is support of these alternate fuels, which are being mentioned until now since morning in different groups to power the hybrid power generation. So onshore power supply simply can be defined as the replacement for auxiliary power engines, which are generally used while berthing of a vessel in a port. So these auxiliary power engines also use the HFOs, which are being mentioned in the various papers, and cause a high pollution and also some serious vibration problem in the ports. So this can be replaced with the more productive onshore power supply, which is very silent and at the same time non-pollutant. To this OPS system, there are some critical barriers in the real time to achieve this. Actually, like the technical, economical, managerial, regulatory, and environment barriers, which are like, for example, there is a small mention of the sockets of different commercial sockets which are being used for different nations all over the world. So different vessels and different type of vessels, actually different vessels from different flag nations and different vessels of different types like oil tankers and container carriers have different types of electrical terminals and the power supply system in their system. So we can't commonly connect this onshore power supply to all the vessels. So there are some technical barriers which are need to be worked out still to supply this common power. And also we know that the power grid, like in India, in a developing nation, there is a common power grid like 50 hertz power and 230 volts, which can't be suitable for the vessels which are mostly using 60 hertz. So we use a converter in middle to convert this power to supply it. So there are some technical barriers which are need to be clarified still. And like regulatory barriers, we know according to the Marpol NHS 6, we need to control the coastal line pollution, but at the same time there is no mandatory rule to supply this shore power in all the ports. So our concern in this paper is about the coastal preservation of the ports in all the developing nations. So economical, we know the economical barrier is even more while supporting with alternate fuels. But since the nations are going towards generated right now. So, role of the stakeholders. We know shipping industry is the major pollutant in the entire world, and the stakeholders of it are also the stakeholders of the shore power supply, like the governments, the flag nations which are taking the policies up, and the shipping companies which are trading, and the logistics which connects both of these. But there is a another entity which which plays an observant role, but yet it is very powerful in its position, like the power department. There are different energy trading companies, private companies, which are interested in renewable energies. Yet they are trading the energy, not supplying to the port, not supplying at the domestic rates, the available economic rates for the shipping. So the consumption of these energies from private companies to the ports may not be feasible for every developing nation. So government policies. So we understand that governments by themselves should power the alternate fuels in the grid and supply to the port in order to show supply. So, for example, India taking a largest developing nation, we have a large coastal line, and for example, we are taking seriously the COP26 rules laid down, and the Vision 2030 we have to decarbonize it by a major percentage, and by 2070 total decarbonization and total power replacement by greener and renewable energy. And we know that carbon credit and taxations are being already in the market for the goods which are having carbon production more in their manufacture and supply are charged more, and which reduce or net zero are credited more. They are given more financial support in order to place in the market. So these government policies in the developing nations are changing in accordance to the shore power supply, which already needs the government needs to establish anyway they have to establish the power grids over renewable energies and the alternate fuels. So these can be also be supplied to the shore supply. The coastal shipping, as we can understand the developing nations, and even more I can use the word emerging nations like India, Japan, even China and USA are using the USA as a developing nation, we can't mention as an emerging nation, are using the coastal shipping more and more day by day. So this coastal shipping is proposed in our paper rather than the overseas shore power supply, like a Singaporean vessel, if it has come to the Indian port and being supplied the shore power supply using greener energies, the credit might go to the Singaporean flag nation because it is maintaining the greener vessel, like greener systems in the shipping. The flag nations are being supporting these green initiatives might not get the enough credit in order to sustain themselves in the international markets, and there is a fatal need of getting the financial supports in the international markets or the international goods. So better first every developing nations should develop the greener initiative using for this shore power supply to the coastal shipping first. So these are the Sagarmala and Bharatmala projects we know which are being initiated and which has increased the coastal power supply initially in our country. And this graphical representation of growth in coastal volume in India. Concluding, to take advantage of the decarbonization of the powering sector in our developing country, it is a major use for the shipping industry to take the case of onshore power supply to get the more and more investment. Thank you.
Thank you, Chennai. D2, one question before I open the floor to other delegates. Have you done any study on the percentage of fuel which is consumed when the vessel is alongside the port and able to pour shore power as compared to the overall fuel consumption? Is there any such data being done in your member state? If such is there, please do share it, as it would be give an indication of what percentage of benefit could be utilized using this. D2, you're there? D2, if you have bandwidth issues, I could suggest you can switch off your camera. You may have better connectivity then. Okay, I think you're back on.
Yes, sir. Sorry for the interruption. Actually, the network here is poor.
So if you're facing that problem, my suggestion is you could switch off your camera. You would get better connectivity. Yeah, B1, the floor is yours. Please go ahead.
Thank you, sir, for the opportunity. We would first like to appreciate and extend our support to your work on cold ironing. It is indeed a great future prospect, but we would like to give some inputs in the research as according to the IOP Science organization, shifting to shore powering from high sulfur fuel still increases 12% of carbon dioxide emission, and shifting from low sulfur fuel increases to 40% of sulfur dioxide emission and 17% of carbon dioxide emission. Though safer but still contributing to GHG and can't be neglected. Also, the power supply demand cannot be fulfilled by every port. Hence, for the current scenario, it's a bit questionable. Though we would like to extend our support in developing a better battery, such as sodium ion, which is the next big thing in replacing lithium ion, as we do believe it's becoming dangerous.
D2, would you like to respond?
Pardon, sir. Actually, we were unfortunately unable to listen due to the network issue. Could you please repeat the
Okay.
question?
B1, if I understood correctly, but I think what D2 had mentioned is that it is linked to the fact that the shore power is becoming more and more towards green power. So I think their vision is to use green power from shore to supply to ships. In which case,
Yes.
is my understanding correct, D2? In that case, it will not be a replacement of low sulfur or high sulfur fuel by coal, let's say coal generated power. So does that address your query, B1?
No, sir, but actually, there can be different ships with different fuels working on it. So when they are berthed on the port, the emissions still happen. That's what my point is. Because they haven't generalized a particular fuel of ship that is berthed and they would shift power to that ship. They have just went on generalized term that every ship that is berthed on the dock would be power supplied. So in case of high sulfur vessels and low sulfur vessels, these two problems arise. That's what my point is.
If they supply the power, it is on the assumption that the ship does not run its power plant.
No, sir, but still it has some emissions from the residues inside the ship. That was this IOP Science organization was researching on. So I read this article.
Okay. I would suggest then please do some research, and if there is some query, please do raise those questions. E4, the floor is yours now.
Thank you, sir. Thank you, sir, for giving me a chance to execute my ideas, sir. And D2, it was a great presentation, but I do agree till the term where you told that shore supply can't be used in all ports, and even some electrical factors such as voltage and frequency, the requirement and arrangements will be different for all ships. So we can't be using in all the ports and ships. But I do like to raise a question on and like even social place they have rules and regulations to operate. Let's just say Europe has less rules and where US have stringent more rules. So how does your idea is going to comply on this? So I'd like to know about it, sir.
Are you there, Chennai D2?
Sir, actually, I'm so sorry. I have been speaking from my teammates. Could you please I can answer the question, brother.
E4, can you please repeat the question?
Yes, sir, sure. D2, my question is like even shore supply, it has different rules and regulations, right? So
Yeah.
let's just take Europe. Europe has different rules and US has different rules. Now I'm asking how your idea is going to comply with that. How your rule is, how your idea is going to compensate with those two.
Yes,
You
actually,
can.
what you said is right. Actually, the regulatory bodies over the developing nations and developing nations are entirely different, and their goals are also different, visions are different. But the common achievement is still there. Like the COP20 isn't happening with the global leaders until and unless there is an initiative to make a common laws. So the IMO itself has been initiated with a common interest in the world shipping. So better these are going to the common point where the developing nations also should be available to pursue this change rather than isolating themselves. And also there is a promise of a Paris Agreement where the developing nations have already promised $100 billion each year, especially USA to the developing nations in order to sustain the development. And this COP26 meeting also has ensured that it is completed. So better these regulations have been coming into the commonplace because, as I said, the carbon credit and taxation system is already there. The international trade is being affected with the carbon units that are being used for the manufacture and the supply chain. So when the trade is itself impacting, how can the laws not be impacted commonly? So I think I
Thank,
made the point.
thank you, D2. Just from the secretariat also, I can give a bit of an input. Yes, a lot of ports are having the facility of giving shore power, including in India also. And I do know that there has been very collaborative work between ports and the Directorate General of Shipping also to develop the systems so that this issue is addressed. And definitely at international level, it will be something of standardization of the nature so that it does not become that because you are coming from this country to that country, the systems don't match or talk to each other. So that aspect will be taken care of if that is your concern, E4. Does that answer your query? Uh, of course, there may be submissions made to the IMO with respect to proposals as to what would be the most feasible mechanisms for developing these common guidelines for port infrastructure to be developed to be able to deal with supply of shore power to vessels visiting their facilities. If for your hand is still up, if you got anything further, please take the
Yes,
floor.
sir. Yes, sir. I will agree on this point, sir. Well, I have one more question for D2, sir. Can I?
Yes, sir. Please go ahead.
So D2, you have been talking about reducing emissions in shore area, right? So my question
Yes,
is,
sir.
the ships which you include is like containers, bulk carriers, which you can supply shore supply from the port itself. But what about the ships like VLCCs, ULCCs, and gas carriers? Even though it's not coming to the port, they are somewhere nearby the port, right? So of course the emissions which is produced slightly near the port area, it will come and affect the places nearby shore. So what are you going to do? Do you have you included this LCCs and ULCCs in your idea, or you're excluding it?
Yeah, but actually that was also a concern, but we have excluded it until a limit because first step in initiating this OPS should be for the coastal shipping and importantly the port vehicles like tugboats because the more pollution rather than this ULCCs and VLCCs is more, but compared to the tugboats which are generally used every day, is not impacting that much to the coastline. So to preserve the coastline, maybe first this should be our initiative because step by step it can be initiated. Or else if we directly target the large going vessels and overseas going vessels and the ULCCs if we target, this might not be feasible for the government also to initiate. So taking step by step, first we are considering these coastal ships.
Thank you, D2. Yes, I suppose that could depend on member state to member state, depending on their exposure to the amount of trade, etc.
Yes,
And
sir.
I'm sure member states would be doing their own analysis and coming out with the best solution for themselves.
Yes, sir.
Thank you. Seeing no further cards on the table, I would now invite Kochi E4 to take the floor, please.
So good afternoon everyone, present here and all the team personalities and the respected delegates. I am Syed Yusuf Ahmad. I'll be representing team E4 Kochi. So in this paper, we have considered US as a base and has focused on step-by-step analysis of GHG emissions from the ships, and based on the study of these GHG emissions, we propose alternative fuels that can be implemented in the future. The IMO initial strategy says that the organization vision reaffirming the commitment to the reducing GHGs from the international shipping while continuing efforts to phase them out as soon as possible over the century. Under this ambition level, the initial strategy is intended to achieve the mitigation of the volume of total annual GHGs from the international shipping by at least 50% by 2050 compared to 2008. The ocean plays an important role in the rate of greenhouse warnings. It does so by absorbing excess greenhouse gases from the atmosphere. As you all know, carbon dioxide emissions from the shipping line are almost more than 3% of the global carbon dioxide emissions. 80 to 90% of the global trade occurs through shipping and hence is vital to the world economy. Due to the scale of the sector, shipping represents 3% of the total global greenhouse gases emission. Therefore, strict environmental regulation around NOx, SOx, CO2 are said to cause major technological changes in the industry. EXI, SEMP, and CII, which only focus on reducing GHG emissions from the existing fleet and marking improved progress towards improved energy efficiency and reduced fuel consumption, and with the help of alternate fuels, we can achieve zero carbon emissions. As you can all see, the adoption of EXI was started from 2021, and in 2023, the comprehensive and compliant technical file on board the vessel to be presented during first annual intermediate or renewal survey of IAPPC or IEEC on or after 1st January 2023. And from 23 onwards, it is applicable for both all the vessels like who has more than 500 GT must demonstrate operational CII index. Coming further, I'll be talking about the enhanced method, how we can improve efficiency. So EXI is nothing but energy efficiency existing ship index. It helps to reduce the carbon emissions, which is covered by three factors: power of the main engine, reference fuel of the ship, fuel oil consumption. Verification will be taken care by the classification society on behalf of flag side. If a ship doesn't comply with the EXI, port can fine or even detain the ship. EADI, Energy Efficiency Design Index, applies to the ship who have greater GID above 400 engaged in international waters. Ships delivered after 1st July must have EADI. How can we attain EADI? Should be calculated for new ships or ships went for a major conversion. Fishing vessels doesn't require EADI. IMO rules and regulations are taken into consideration while calculating EADI. In the end, an EADI tech file will be verified and given by the administrator or by any organization. CII, Carbon Intensity Indicator, based on the annual fuel consumption, and from January 2023, it should be reported every year. Carbon intensity is nothing but the measure of ships' GHG emissions with respect to the cargo amount over a certain distance. CCAI is nothing but calculated carbon aromatic index, is the calculation of density and viscosity of the fuel. And SEMB is nothing but Ship Energy Efficiency Management Plan, an operational measure which invents a mechanism to enhance the energy efficiency. As you can all see, this IMO 2050 timeline and actions. It was started from 2015. By 2050, the planning to reduce the emissions as soon as possible. So moving on to the next slide, slow steaming measures. One of the short-term operational measures for reducing CO2 emissions from ships at sea is sailing at reduced speed. That is slow steaming. A study was conducted on a container ship with a route through the Mediterranean Sea and was found that maximum efficiency when the container ship had a speed less than its stated speed. Thus, the reduction of a fuel consumption and CO2 emission is assessed in calm water and waves for the design speed and slow steaming speed. Besides the slow steaming approach, liquefied natural gas fuel ship are technically the most practical alternate for reducing CO2 emissions in deep sea shipping, which account for more than 80% of the world fleet. For this purpose, LNG fuel ships in the deep sea segment are powered by dual fuel two-stroke engines, for example, man gas diesel or Wärtsilä dual fuel, where the former reduces GHGs up to 20 to 24%, NOx up to 25 to 30%, and SOx up to 90 to 97%. Reducing ship speed by 10% will lead a 27% reduction of the ship's emissions. Overall, if all ships were to slow steam, the available capacity on the market would be reduced, and if the additional emissions of building and operating these new ships were considered in the equation, then reducing the fleet speed by 10% would lead to overall CO2 savings of 90%. So the data analysis which we have made here is like we have taken as USA as a base model here. So according to the USA base model, how as India as a developing nation can adapt those things. As you can all see the graph here, first from 1990 to 2015, the emissions is very high, and now we are planning to get up to zero emissions. So that is possible. So each goal serves an important milestone toward rapidly reducing our GHG emissions to net zero. While this report emphasizes the longer period of 2021 to 2050, the overall US strategy integrates action for both near-term and 2050 goals. The 2030 NDC of 50 to 52% reduction below 2005 levels, covering all sectors and all gases. The goal for 100% carbon pollution-free electricity by 2035. The goal for net zero emissions no later than 2050. The report draws from a diverse analytical toolkit integrating insights from a global integrated assessment model covering all greenhouse and economic sectors. This is why the United States set an economy-wide target of reducing the net GHG emissions by 50 to 52% below 2005 levels in 2030. This 2030 commitment anchors the US approach during the decade to build a sustainable, resilient, and equitable economy by rapidly developing widely available low-carbon technologies and investing in the infrastructure, innovation, and workforce that is the foundation of this economic transformation. LNG as fuel. Switching to LNG as fuel can provide significant advantage by meeting regulatory requirements, offering enhanced competitiveness, as well as improving overall air quality and reducing GHG emissions. LNG fuel vessels can reduce the EEDI rating by 20%, while the carbon intensity indicator will be reduced by approximately the same amount. Competitive vessel design ensures upcoming compliance, some 10 years longer than conventional designs, reduces NOx emissions by up to 80%, and almost eliminates SOx particulate matter. CO2 emissions can be reduced by up to 23% with modern engine technology. Biogas and dropping fuels offer a path to further reducing vessel carbon intensity. To capitalize on these benefits, it is important to choose the technology that fits your vessel type and operational parameters. With researchers going on, further advancements can bring out better results in future. Hydrogen as fuel. Hydrogen is commonly produced by converting natural gas or coal into hydrogen as an CO2. Although for the long-term sustainability goals, renewable energy can be used to generate hydrogen through electrolysis. Hydrogen is characterized by having the highest energy content per mass of all the chemical fuels at 120.2 megajoules per kilogram. Compared to other marine fuels in terms of mass energy, it exceeds MgO by 2.8 times and alcohols by 5 to 6 times. Therefore, hydrogen fuel can increase the effective efficiency of an engine and help reduce the specific fuel consumption. However, on a volumetric basis, due to its lower volumetric energy density, liquid hydrogen may require 4 times more than MgO or about 2 times more space than liquefied natural gas. For an equivalent amount of carried energy, also important to consider when comparing fuel energy and required volumes are the energy efficiencies of the consumer or electrical energy losses in fuel cells. So we would like to propose these things in our presentation. India being a country that involves much in shipping, developing and implementing the plan sooner can help in the country's economic growth. The report draws from a diverse analytical toolkit for integrating insights from global integrated assessment model covering all greenhouse and economic sectors, a national CO2 model with high resolution on the electricity sector, models of US and land sector more and the same could be adapted by India. LNG, even now being much eco-friendly, could be improved further with the technical advancements. Clean green hydrogen through electrolysis with future technicalities on board. Development of prototypes in the meantime is feasible. Thank you.
Thank you very much, Kochi, for giving us the roadmap, which in your opinion would we continue with LNG while you work on future fuels. Is that what you would like to summarize your presentation as?
Yes, sir.
Thank you. I open the floor for discussion. C3 Chennai, the floor is yours.
Yes, sir. Thank you for the opportunity, sir. I would like to appreciate the team for proposing EEXI and EEDI impositions, and if they are not complying with them, imposing a fine on them is a really good idea. And further, I would like to come to the point regulating the speed of the vessel. I would like to ask the team by regulating the fuel, doesn't that affect the global trade of the world as shipping is mostly dependent, global trade is mostly dependent on shipping. So, yes.
Thank you, C3. Just from the Secretariat, I think I can give you some insight. EDI, EXI are existing regulations. There is no question of non-compliance. They are existing methodologies. And considering slow steaming is something which came into being during recent times, and it has two impacts. One is if you take more time, then obviously, then possibly you get more ships into operation for transportation of the same cargo, vis-a-vis the reduced fuel consumption and its effect on the uh, emissions. So it's a balance which works to some extent, but then finally it's a commercial venture, and uh, container fleet was the one which did slow down, and those have been market-based things which have done that. We do not wish to get into certain areas which are transient in nature and would change with market scenarios, because those are chartering requirements, and we do not think that it would be the appropriate for IMO to be looking at those aspects. We would look at sustainable uh, measures which could go along in the future. And needless to say, reduction of power of a ship also has to take into account the safety of navigation. It cannot be taken in isolation only for the aspect of MARPOL. It has to take into account safe navigation, adequate power to be able to maneuver, especially in places where such maneuvering is critical for the safety of the ship and of the life or property around, life of personnel on board and ashore. So I hope that does clarify a bit. If there's anything else you would like to ask, C3, please go ahead.
Also, thank you. We've been clarified. Thank you very much, sir.
Thank you. B1, your hand is up. You have the floor.
Yes, sir. Thank you, sir. The proposal to promote slow steaming looks impressive, but in the same article, your team referred to obtain the supporting data. We will need to introduce more fleets to compensate for the slower speeds to satisfy the world demand. Now the introduction of new fleets have now available data on GHG emission. Hence, there is no proof that it is viable to opt for such slow speed engines. Also, this totally neglects the chances of introducing LNG as a fuel, towards which the industry is heading, because slow engines need longer stroke enhancing combustion time with increased possibilities of methane slip. But since your efforts are towards dealing with the engine to reduce GHG, which is parallel with our study too, we would like to have your support on developing better engine standards for a better future. Thank you.
Thank you, B1. D2, the floor is yours. And then after, I'll ask E4 to come back together on both your points. Yeah, D2, please go ahead.
Yes, sir. Thanks for the opportunity. And it was a nice presentation, brother. Actually, I have a small doubt. Like in context of a developing nation, LNG isn't available, supplied, and distributed enough for the domestic purpose itself. How may it be available continuously without any interruption for the trade on a large scale for the shipping industry? The time limit is also very less. Like you said, like reduction has been targeted by 2050 to 2070 itself. So all over India, the plan should be established and the supply line should be more efficient rather than right now. So do you think it is possible to be that much efficient from the timeline that you have shown?
Uh, E4, you want to respond? Thereafter, as a secretariat, I can respond.
Of course, sir.
E4.
Thank you for the opportunity, sir. Sir, in case of LNG, to be frank, India is already in the verge of a vast LNG pipeline network, which with the transportation issue could be solved. The only issue which we are going to face is the production, for which India will need support from the other developed nations.
Okay, to add on further to what E4 has said, I think in India the primary LNG distribution network GAIL does do that, and there is at least Cochin is one major place where even bunkering of LNG is taking place. So while the onshore pipeline network may not be as extensive as in developed countries and US, but yes, to some extent it does exist across the country. And those are infrastructure developments. If LNG works out as a fuel, irrespective of methane slip and technical solutions and all come up, is sure the infrastructure having been developed to a large extent would be further augmented. This I am talking specifically as India, not as IMO Secretariat, but generally for LNG, the vision was very strong, and it's a fact a lot of investment has gone into that sector. The present issues with respect to methane slip and life cycle analysis is what is possibly making the other fuels also become more competitive in the area. That is a general comment of mine. I see no further hands, and I see Mr. Ramamurthy also wants to augment something. Sir, please.
Yeah, that's. I just want to give some information.
Yes, sir, sure, please. Your knowledge in
Slow
that
speed
range
is
is excessive.
slow speed is not something new. I remember India was the first one suggesting for slow speed. At the time, IMO, there were MEPC, there were no takers. In fact, some of us, they were even laughing. The point expressed by you, we are going to affect the trade of shipping in the world by slow speed. So I remember in MEPC 48, I think, in 2005, I think I was also, I think, part of the Indian delegate. India was the first to suggest on slow speed. This is just for the information of the people. Many of you people might have been toddlers during the time. I think that this information from you for all of you, just for taking. That's it.
Sir, you have just refreshed some memories. I have worked on engines which had special slow speed nozzles, Sanzar, R&D engines. We had different nozzles for fuel nozzles for main engine for running on slow speed, and different fuel nozzles for running on normal speed. And it was a practice out there that you could change the nozzles depending on the trade pattern and run the engine efficiently. So possibly those things are out of fashion now or being overtaken by other technological means. But in those times, we used to do that, and it used to be possibly a 6-hour exercise to just open the fuel valves, change the seats, and change the nozzles, and get the engine changed over to a slow speed, efficient running, because the characteristics of the engine changed with slow speed and high speed running.
I just want to add to that. At that time, the idea was to really save the fuel.
Fuel.
And on that, it was not the present point of view of, I mean, reducing the carbon footprint. But all this one came later with the reducing the carbon footprint, the idea of slow speed came. At that time, you are absolutely right. And we were having different nozzles for slow speed cleaning, all that, for better combustion and better fuel efficiency, so that we were having it. Absolutely right. But the context was different at that time. Thank you so much.
Thank you, sir. That is what I value most about such sessions. It brings about a lot of knowledge sharing, and I hope there are people watching on the YouTube also who feel that they get value. And of course, I think Mr. Datta also experienced different nozzles. Thank you very much. With this, we have reached our third session conclusion. To summarize, we had first Kolkata B1, which acknowledged the issue of methane slip and came up with some innovative solutions on how to deal with it. We would be very happy to hear with further progress and research done on this, and as experimentation clears it out, we would definitely like to keep sharing that knowledge and also on the views on carbon sink. So we look forward to further submissions on that for information as well as in case any further action is required at that front. Chennai C3 talked of methanol and how that could take the role of a future fuel, an environmentally friendly fuel. Methanol based engines is something on which possibly they are still in the research phase, and we would like to hear more from them as their research bears further fruits and they get more knowledge. And even if they are trying out trial reports, etc., to get other member states to sort of embrace that technology. Chennai D2 talked of shore power supply and rightfully recognized that it would be most important to first put it on the coastal vessels and the harbor crafts, etc., so that immediate effect could be done. But slightly a view from the Secretariat that we should look at international. You may be having one VLCC of a foreign flag coming, but if you have a VLCC coming every day, the impact is again a everyday impact. So while it's always best to catch the low-hanging fruits, we should look at all aspects of shore power supply. We recognize very rightfully the points you have raised regarding the technical difficulties, etc. And there should be a cooperative effort amongst member states, and we invite submissions so that universal application of shore connections and all. Shipping is no stranger to these. We have had international fire connection, international Marpol connection. I am very sure in electrical field also we will come up with an international structure which would be suitable the world over. We have finally Kochi E4 talking of LNG fuel and with hydrogen as the future. Uh, we look forward to their further work on hydrogen and their submissions on that. With that, we are now close to our tea break, and as per original plan, we are supposed to reschedule and start at 3:30. Do we maintain that, Gaurav? With the judge's permission, then we take a tea break and we are back at 3:30 for the last session of the day.
I am okay with that. I hope others also agree.
Yeah, no problem.
Yeah, fine.
Okay, sir. No issues.
No issue.
Yes, sir. You can.
Okay, so we break now for tea, a well-deserved tea for everybody, especially after lunch session, and we look back to meeting everybody at 3:30. Thank you very much.
Thanks a lot.
Mr. Mehrotra, you have something? Okay.
Sir had tea.
Yeah, we all had tea. Yes.
Okay, okay.
Yeah. I saw actually Mr. Malhotra being served tea. Also, I saw that. Very beloved. We just watched it actually. So,
How is the weather there in Bombay today? No rain, no? Hopefully.
no, Bombay there is no rain. Nice sunshine.
Yeah. Calcutta weather is good. No rain, nothing.
It's a long day. Long day.
Long day, sir.
I just had a shower also.
Tomorrow I think it will be less, no? Because
Yeah,
people are
12,
less.
12, 12, 12.
Tomorrow by 3 o'clock we should close.
It should be
Yeah.
over. Yes, sir.
Now, who had coffee or who had tea?
I had tea.
You know?
I had tea.
But this was supposed to be a tea break and not a coffee break, so I had tea.
I had
They
tea.
announced tea break. I had a shower also.
For me, it's a coffee break, you know. That too, filter coffee, you know.
Filter coffee. That's not coffee, that is copy.
Coffee,
Copy.
right. And coffee by the yard. You
Yeah.
Still 3 more minutes.
Uh, so shall I start with the
Yeah, the boss is here. Yes.
Boss is here.
He's
Boss
back.
is back.
Chair. Mr.
When
Chair.
When
Yeah,
Rajiv sits like this, it
yeah,
reminds me.
he's not wearing a jacket.
When Rajiv is sitting, it reminds me of IMO plenaries where Mahapatra and other MEPC used to sit on top with their headphones. Only thing, he has not shaved his head.
Yeah.
I think Rajiv is having some cold, I think, the chair.
Yeah, he's sneezing.
You
Why?
are. I could make out that not only you're sneezing initially, by rubbing your nose, I can see the difference.
Rajiv,
After
next
5,
time
6
in the next
months.
year, make it mandatory to shave your hairs also when you are sitting on the chair, like Mahapatra and now Raji does. Clean shave.
But I have not gone bald, I'm 77.
अरे सर आप तो राजा आदमी हो.
No. It is hereditary.
It's hereditary, yeah.
Yeah.
We go grey, but we never go bald.
You are muted, Rajiv. You are muted.
So with your permission, may I?
Sir, you require to see your junior's heads. Then you will know the effect.
Right, sir. With permission of the judges, I'd like to begin session number 4 of MEPC. There are 5 teams in group 4, and these are Kochi A2, B2, E1, Alpha 2, Bravo 2, Eco 1, and Mumbai 2 zone has C2 and D1, Charlie 2 and Delta 1. The Kochi zone guide for MEPC is Mr. Devgroup Kavi, who has already been introduced. The Mumbai 2 zone guide is Mr. David Birwadkar. Mr. Birwadkar began his career in 1983 as junior engineer and has extensive sailing and shore experience. He is presently advising Great Eastern Shipping, having superannuated last year in April, before which he was vice president heading the training and assessment department for the past 15 years. Mr. Birwadkar is also an extremely active member of the Institute of Marine Engineers India, being the convener of the quadrennial in Marco 22, the International Maritime Conference and Exhibition, which is the flagship event of the Institute of Marine Engineers India. I now hand you over to Mr. Rajiv Nayyar, who is the session chair for the 4th session. Over to you, Rajiv.
Thank you, Gaurav, and welcome back, ladies and gentlemen, to the 4th and final session of the day. I invite Kochi A2 to take the floor and introduce their paper.
Kochi, we cannot hear you.
Sir, hello, am I audible?
Very low. Increase the volume.
How about now, sir?
You will have to increase your volume.
Sir, am I audible now?
Yes, better. Go
Little
ahead.
more if you can.
Sir, is the presentation visible?
Yes, please go ahead.
Yes. Good afternoon to the respected chairperson, the honorable dignitaries, and other delegates present here.
We thank the Honorable Chairperson for giving us this opportunity to present our proposal to IMO MEPC. We are delegates of A2 Kochi and us being developed state propose a comprehensive study on marine alternative fuels with an emphasis on green hydrogen as a fuel for the future. This is an overview of our proposal paper. We'll be talking about selected contents and certain topics from the paper in this presentation. Climate change is a real crisis. We have been experiencing adverse effects of climate change for the past few decades, and it's exactly the reason why we are sitting here and having this discussion. Now, to curb climate change, we need to look forward to achieving net zero emissions and decarbonization. Maritime, being the backbone of international trade and global economy, is switching to greener shipping as to comply to the IMO's regulations and GHG strategies. Now, the industry has two ways to approach this goal. One is through technical operational methods where we modify the existing equipments and the equipments being developed so as to comply with improved EEDI, EEXI, and CII. But if you're looking for a long-term solution to achieve net zero emission, we have to look to switch to alternative fuels. And life cycle analysis of alternative fuels play a vital role in deciding the value chain adaptation and to ensure that no carbon footprint is produced from the well to tank and tank to wake or the fuel. We have applied a five-step process in choosing the alternative marine fuel and also assess parameters like applicability, economics, environment, and scalability under the topic of alternative marine fuels in our paper. Based on these parameters, hydrogen, ammonia, biofuels, methanol, LPG, and LNG are the options that shipping has. Out of these, hydrogen and ammonia are the most promising fuels, but it is to be noted that green hydrogen is the only fuel which gives out net zero emissions. This table that you see on screen is a comprehensive study about the parameters being met upon by various modern alternative fuels, and you can see that alongside GHG and local emissions, only hydrogen gives out net zero emissions. That is, it has no GHG emissions and local emissions, and it is not toxic at all. You might notice the red circles that you might see against the parameters under hydrogen, but these can be, we assure you that these can be improved through improved economic strategies and further development. Table that you see on screen now shows the technical properties of hydrogen and how it fares against other alternative fuels. You can see that the energy per unit mass of hydrogen is 3 times that of gasoline, while it maintains a flame velocity of hydrogen 8 times faster than methane. The ignition range is 6 times wider than methane, and the ignition energy required is just 1/10 of that required by methane. We see two diagrams on our screen now, and the left one shows a compressed hydrogen system, and the right one shows a liquid hydrogen system. This is basically a prototype of how hydrogen system can be implemented on board, and this is an integrated unit starting including even the storage of the fuel to safety systems and even hydrogen detection in case of leaks. Next, we see a block diagram of the fuel cell power system that is to be implemented on board. We can see the different components and pathways that it has, that the fuel cell power system adoption has. Green hydrogen. According to the Future Fuels for Power Generation Survey Report 2022 done by Man Energy Solutions, 59% of 577 subscribing organizations agreed that the hydrogen is the most important fuel of the future, and 75% of 524 subscribing organizations saw green hydrogen as a fuel for power production. If you look at the rest of the survey, we can easily come to the conclusion that green hydrogen is the best fuel for the future and is the most favored by subscribing organizations. Hydrogen, let's talk a bit about the benefits of using hydrogen as a fuel. It emits no GHGs, no local emissions, and no particulate matters. The only byproduct achieved when we burn hydrogen is water, and it has high energy per unit mass value. It can be produced from renewable electrical energy, and hydrogen is an established commercial product on land, which gives us a basic framework of how to handle hydrogen. It is highly buoyant, and therefore, in case of leaks, it disperses very easily, and it is to be further noted that hydrogen is not toxic to humans at all. But in case of higher concentration, it can act as a convenience, and only in cases of higher concentrations. To the recommended strategies, green corridors are to be established in LDCs and SIDs to and developed states which already have established green corridors are to provide guidance to LDCs and SIDs because green corridors help in decoupling decarbonization and trade growth over a period of time. Now, member states which have an abundance in fossil fuels can generate hydrogen and implement CCUS technology to keep the GHG emissions to a minimum. Revision in training modules is another important part of the process because hydrogen is a relatively new process and seafarers must be extensively trained in handling hydrogen, its behaviors, its safety issues, the risk assessment, and the counter measures to be adopted in case of emergency. If possible, these training modules must be integrated in maritime institutes and also these modules must be made openly accessible to all. Actions to be taken by MEPC. We have discussed several actions to be taken by MEPC in our proposal paper. We'll be discussing about a few here. The committee should continue to provide mechanisms for facilitating information sharing, technology transfer, capacity building, and technical cooperation, taking into account Resolution MEPC.22965. The organization is requested to access periodically the provision of financial and technological resources and capacity building to implement the strategy through ITCP and other initiatives, including GLOMI project, MTCC network, and the Green Voice 2050. The committee should stress on market-based measures and practical technical requirements of the ship owners. The committee should ensure proper regulations and operations of both IMRB and IMRF by considering case by case of individual member state. Most importantly, committee must promote the proper information graphics of IMO resolutions regarding GHG emissions, its reduction strategies, and net zero emission goals via member state. Green hydrogen, adopting green hydrogen as a fuel is a long-term strategy. We have to play the long game here. It is the best way to achieve our goals of net zero emission. And with increasing pilot projects, increasing investments and research being conducted, we are gaining more and more experience and expertise on the matter. The ISO technical report 15916 can be used as can be used for technical info on basics of safety of hydrogen systems. Furthermore, we member states and the maritime industry in itself is looking for alternative fuels, and hydrogen is the best alternative fuel. Green hydrogen, let me emphasize, green hydrogen produced from renewable electrolysis of water using renewable electricity is the best way that we can tackle climate change and we can contribute to tackling climate change and achieve net zero emissions. Thank you. We'll be now opening ourselves for interventions, suggestions, and collaborations from our delegates and fellow panel members. Thank you.
Thank you, Kochi A2, for enlightening us about green hydrogen. I open the floor for interventions. I see C2, Mumbai Zone 2. The floor is yours.
A very good afternoon, respected delegates and panel members. First of all, I would like to congratulate the delegation from A2 on their extensive research, and the suggestions are valid and in line with current scenarios, and we appreciate the sincere efforts in bringing this up. At the same time, we would like to extend a heartfelt gratitude to the Green Corridor mission, especially for Green Corridor mission, especially because it is in line with some of the suggestions we're going to bring up later. The only clarification we need is shipping decarbonization has various moving parts, and one of the challenges with decarbonization and especially the green corridor, the deployment of these solutions at scale with industry which is diverse, desegregated, and globally competitive. At the same time, I would also like to raise the points about hydrogen as an alternative fuel, as hydrogen is stored at almost minus 253 degrees Celsius, while the maritime sector only has experience with temperatures up to minus 10 times higher, and also very expensive. It's also very expensive considering your production methods that you mentioned also. How would we get over this compared to to fuels like ammonia and LNG, which are being used right now and also have very less emissions.
Uh, would you like to respond to that, Kochi A2?
Yes, sir, of course, we do.
Yeah, the floor is yours, A2.
Thank you, Chairperson, for giving this flow. So, before responding the interventions, we have to clear like the morning session we are discussing about the alternative marine fuels. So, by comprehending the whole session, we can come to the conclusion that there is no perfect alternative fuel exist. We have to compromise on one or two things to achieve a net zero emissions by 2050. So, talking about the first question you raised, first intervention you raised, that green corridors. Already, the developed member states like United States and European unions have already established these green corridors to prioritize the green fuels. Coming to the developing member states, these green corridors should be introduced in such a way which are interconnected with the special economic zones of that member state, so that it can be aids by the other uh, requirements of the maritime industry. And to talk, and coming to the second point, that storage thing, we have to compromise with the storage, 2% of the cargo. But NASA and the recognition organizations have already initiated projects on these existing Type C tanks with a uh, extra insulation, like with a extra material insulation, because hydrogen has a property called metal embrittlement, which can be like demade for hydrogens. We have clearly mentioned in the section fifth of the codes and regulation standard section that all the in what way the standards of the insulation and the storage should be met upon. So we hope like we cleared your clarification of the intervention.
Thank you, A2. And I see the card of E1 Kochi is also up. E1 Kochi, the floor is yours.
Thank you, sir, for providing the opportunity. As you have mentioned about the proton exchange membrane, and as far as we know, proton exchange membrane requires a expensive catalyst that will raise the overall cost. If we compare it with the other fuels like ammonia and coal, it will be very expensive along with the vast amount of space used for this. And how you see this? And also, you have mentioned in a paper that the cost of hydrogen is much higher than the ammonia. Then why will we the owners prefer hydrogen over any other fuels?
Thank you, E1. A2, you would like to respond?
Yes, sir. Yeah, yeah. Yes, sir. We do. Like we are like to clarify on that topic.
Go ahead, please.
Thank you, Chairperson, for giving this floor. Yeah, delegate, a member from the even state, member state. So we are talking about the price, the economics part of the alternative fuel. As of now, alternative marine fuels, except the HFO and the conventional fuels, the alternative fuel have a high price, expensive for the even for the proton exchange membrane and other things. But we assure, because already the developed member states, like we have already mentioned, like United States and European unions, they have already a significant numbers, like significant figures investment in this, into this in a deep, and they have established a H2 program and H2 scale in such a way that they have to uh, make this as a feasible alternative fuel by introducing the incentives and the policies which can make this expenditure is a feasible one for the stakeholders and the ship owners. And coming to the ammonia part, you like superior, like you was told that ammonia may be superior than a hydrogen. In a the main core topic that we are here and discussing the session is that we like GHG emission. So coming to the green hydrogen, the local emission plus the GHG emissions is very like net sum zero. So uh, we have to compromise, like in the coming decades we have to uh, look forward for ammonia and hydrogen both, and these from the loss of economic and the economic strategies, the price and the expenditure, what we are worrying can be resolved.
Okay, thank you, A2. So that's a input from you on green hydrogen. I now invite Kochi B2 to take the floor and share their views. Kochi B2, please proceed.
Good afternoon, respected Chairperson and delegates of members of state and other dignitaries. I am Benny Benrick, representing B2 MEPC Kochi. Thank you, Chairperson, for giving us the opportunity to present in the IMO MEPC. Today, I am going to present on the topic use of green hydrogen to reduce GHG emission from ship. My team members' names are Mohammed Nizar Sunnat KP, Karthik TS, Ismin Abdullah, Akbar Khan SR, and myself Benny. International shipping contributes with approximately 2.4% of global anthropogenic greenhouse gas emissions, and its share is expected to increase in the future. GHG from ship include mainly carbon dioxide, methane, and dianitrogen oxide, of which CO2 dominates the global warming potential. The development pathways initiated by different countries at all stages of economic development impact GHG emissions and shape mitigation challenges and opportunities which vary across countries and regions. Literature explores how development choices and the establishment of enabling conditions for action and support influence the feasibility and the cost of limiting emissions. Global total emissions are expected to increase due to a higher demand for shipping services. The International Maritime Organization estimates that a 10 megatons CO2 emitted globally per year in 2012 will become between 910 and 1200 megaton in 2030. In the business as usual scenario, no GHG reductions additional to those from the Energy Efficiency Design Index regulations are assumed for visiting ships. After the inventory and the forecast in the BAL scenario, the GHG reduction potential is assessed by applying a number of measures in a series of scenarios. The studied measures are divided into three categories: alternative fuels, design measures, and operational measures. So now we can see the diagram of shipping stakeholders. Our Prime Minister Shri Narendra Modi implemented the national logistic policy, which is vital for our maritime industry. So this shipping stakeholder have different sectors. So these different sectors often benefit from that policy. Producing green hydrogen-based fuels can kickstart the transition to new shipping fuels and can make key down payments that will drive further investments in renewable energy and feed the demand for climate action within the global transportation sector. There is growing pressure to reduce greenhouse gas emissions from maritime transportation. One of the most effective strategies for reducing greenhouse gas emissions is to switch from conventional fuels such as heavy fuel oil to alternative fuels. Green hydrogen is a promising alternative for the shipping industry. Nonetheless, its potential usage will depend on more than its environmental friendliness. This challenge is particularly important for the maritime shipping industry, which account for 7 to 8% of global GHG emissions. In 2018, the International Maritime Organization adopted the IMO initial strategy for reducing GHG emission from international shipping consistent with Paris Agreement. Spin, can you change the slide? So I think you lost this network connection.
I think we will come back to you later. Uh, we'll come back to you later. In the meantime, I'm going to ask Mumbai 2C2 to take the floor while you establish your connections and see your this thing. And then we'll take it up later.
A very good afternoon to all the delegates, chairperson, and respected panel. I, Ansing Rajpal from Tulai Maritime Institute, along with my fellow delegates, would like to present the proposal of establishing the East China Sea as an emission control area. Team C2 established a locally concentrated coastal emission control area (ECA) that capped the sulfur content of marine fuel oil. The three ECAs were Pearl River Delta, Yangtze River Delta, and Bohai Bay. These arise as a matter of C2 domestic law and are not MARPOL annexes designated emission control areas. This resulted in a multitude of benefits to the environment and surrounding inhabitants. Ports within the emission control area had to adhere to all regulations in accordance with Tier 3 emission regulations. This is a domestic law, along with its trailing benefits, was used as a case study for this proposal. Keeping in view the current pandemic and its aftermath, Team C2 submits this document to consider how capping sulfur content in the fuel oil used on board ships operating within the East China Sea, hereafter referred to as the ECS SOx ECA, to 0.10%, that is one-fifth the current global legal limit, would translate to about 78.7% drop in SOx emissions. Highlighted in orange are the SOx and NOx emissions from ocean-going vessels as compared to other industries. And in this slide, we compare ocean-going vessels to river and local vessels. With ships allowed to burn bunker fuel with sulfur levels that are 100 to 3,500 times higher than permitted on-road diesel fuel, SO2 and particulate matter emissions from ocean-going vessels are far higher than emissions from on-road vehicles on a per-unit energy basis. As a result, medium to large-sized container ships running at 70% maximum power from one day using bunker fuel at 3.5% sulfur emits as much particulate matter as the average of 500,000 new trucks in China during the same day. This graph shows the vast difference between sulfur content of different fuel oils. As you can see in purple, this Tier 3 ECA emissions and normal global caps. Regulation 14 of Annex 6 addresses the method of SOx emission reduction, namely lower sulfur fuel oil, exhaust gas cleaning systems, and other technological methods. Three different methods of SOx emission reductions are aimed to alleviate SOx pollution related damage by setting a sulfur limit in fuel oil and total emissions of sulfur oxides from ship. Emission Control Area or ECA is one such method. The world's first to establish ECAs were Baltic Sea in 2006 and North Sea in 2007. The potential annual public health and environmental savings made through these were 8 billion to 16 billion in 2015 and 10 billion to 23 billion in 2020, while the estimated cost of setting up these ECAs was 0.6 billion to 3.7 billion in 2015 and 0.9 billion to 4.6 billion in 2020. As you can see, there's a vast difference. An obvious problem is ship trading in and out of SECA areas because they have to operate on dual fuel oil systems. Dual system operation has serious implications on engine condition, changeover operation, lubrication complexity, and tank segregation. Further, price of lower sulfur fuel oils is another problem as its relative cost is a little higher. It is likely that fuel costs from ships navigating in Sika will increase. The International Institute for Applied System Analysis concluded that the marginal cost associated with SO2 reduction is 0.5 euro per kg of SO2 for ships operating in the South China Sea, which compares favorably to land-based sources of 1.5 euro per SO2, which means that the reduction of SO2 emissions in shipping is relatively cheaper than land-based solutions. Thus, it ensures sulfur reduction as a scheme under SICA is reasonable. A recent report by the Wall Street Journal explores the idea of distributing the excess cost of lower sulfur fuel oil over the supply chain instead of ship owners bearing the entire burden. In this way, everybody can contribute towards the betterment of our environment. This table shows the operating and hardware cost of fuel switching and SCR technologies. There is not a lot of good data to quantify premature mortality due to ocean-going vessels worldwide. A 2019 study based on limited data from 2017 found that global emissions from ocean-going vessels were responsible for an estimated 60,000 premature deaths each year from cardiorespiratory diseases and lung cancer. The same study concluded that more than 15,000 cardiopulmonary and lung cancer deaths caused by ocean-going vessel emissions had occurred in East China in 2017, including China, Japan, and Korea. 54 significant health impacts caused by ocean-going vessels are estimated near the coast of Ceto, where shipping activities are increasingly concentrated, as shown in this slide. The actual number of premature deaths due to ocean-going vessels is likely higher. For example, the US EPA has stated that implementing an ECA around most of the US coastline will eliminate up to 31,000 premature deaths from ocean-going vessels in 2030, compared with projected premature deaths if no ECA were in place. In the EU, international shipping caused an estimated of 46,000 premature deaths just in 2020. Given the US and EU figures, the number in China, with more ocean going vessels, more people, higher pollution levels, and a lack of local or regional control on ship fuels and emissions in water surrounding C2, should be much higher than the above mentioned study found in 2019. This slide shows the spatial distribution of SO2 emissions in tons per year from ocean-going vessels in the Pearl River Delta region. This slide shows the potential benefits of an ECA in relation to reduced mortality and prevention of childhood asthma. The committee is invited to consider the information presented in this document and in particular take under consideration the proposed amendments as set out in paragraph 16, 17 to Regulation 14.3 Appendix 7 to MARPOL Annex 6 on the designation of East China Sea as a whole as an emission control area. Under this, we propose mandatory at-berth fuel switching to fuel with 5,000 ppm 0.5% or less for ocean-going vessels. Mandatory fuel switching for fuel with 1000 ppm 0.1% or less sulfur for ocean-going vessels operating in the East China waters. An ECA covering 100 nautical miles from C2, hence including some parts of Pearl River Delta waters. Furthermore, the exchange of knowledge and experiences with international experts and regulators, particularly on advanced technologies such as selective catalytic reduction, scrubbers, LNG, and shore power, will be valuable in helping C2 policymakers better understand the opportunities and challenges in leveraging these advanced measures. Looking ahead, joint regional, national, and international efforts to control shipping emissions, such as establishing an ECA for major C2 port regions or for the entire country should be seriously considered as a way to address concerns over port competitiveness and to achieve the greatest environmental and health benefits for C2 and internationally. Finally, establishing an ECA would spur the adoption of advanced technologies and cleaner fuels on ships when they are operating in C2 waters, leading to substantial reduction in shipping emissions and contributing to the attainment of C2's air quality goals. Thank you.
Thank you, Mumbai to C2, for your bringing an issue of SOx onto the table here. While I would take this up, will I be able to do a presentation with the rights given to me, or would I be able to present my screen? Dr. Yugmala, can you get it checked in between, because I may have to put a document when I'm addressing this at the conclusion, because I would like to deal with this paper in totality as it's dealing with the specific member states waters which are contiguous with other member states and looking for a special zone to be announced. So there are specific things which I would like to bring to the notice of member states. Meanwhile, I did see a card go off. Does any of the other member states? Yes. A2, the floor is yours.
Thank you, Chairperson, for giving this floor. Uh, by going through the uh, proposal by C2 member state, we appreciate the proposal regarding the SOx emission and NOx emission.
Hydrogen gas reacts with oxygen to produce electricity and water vapor. Because of the hydrogen's capacity to generate energy without releasing greenhouse emissions, it is a potentially clean and alternative fuel in today's date. So to conclude, the shipping industry is itself responsible for approximately 2 to 5% of the total greenhouse gas emissions, which can be counteracted by taking into account the aforementioned points. Based on research, we came to a conclusion that wind power, slow steaming, use of green hydrogen, as an alternative form of fuel can save us from overwhelming effects of global warming due to greenhouse gas emissions.
Sir, you are mute.
Thank you. We are reaching the end of the day. So thank you for sharing the various options, and I suppose as a member state, as you work more on these and have concrete proposals, you could put them up and we will take note of what your suggestions have been. Meanwhile, I do have the cards of C2 Mumbai 2. C2 Mumbai 2, the floor is yours.
Oh, thank you, Chairperson. First, we would like to congratulate the delegates of Team D1 on their extensive research. At the same time, we would like to register our apprehension towards the point of slow steaming. Slow steaming may increase lower engine temperatures and pressure and increase particulate matter emissions. In addition, stated that slow steaming could lead to higher CO emissions and higher sludge impact per voyage. Also note, ships, marine engineers from engine manufacturers were obviously advised that low load operations must be avoided. Engines must be run as close to continuous rating as possible. At the same time, I would also like to extend our support to one of the ideas of using methanol as a fuel, because liquid methanol as a fuel can be stored in a similar manner to diesel fuels with existing bunkering infrastructure and can be converted to methanol at a low capex. So we would like to collaborate with them in the use of methanol as a future fuel.
Right, and
Thank you so much.
I have the card of A2 up. A2, would you like to take the floor?
Yes, sir. Yeah. Thank you, Chairperson, for giving us this opportunity. Dear Delegate D1, we, as the part of Delegate of Developed Member State, we would like to collaborate on your ideas on usage of biofuels as short-term initiative, and we completely agree with your point that green hydrogen holds the potential for 100% emission-free shipping, and also implementation of infrastructure for hydrogen is cannot be done overnight. So green hydrogen is a thing which can be implemented for long term, which requires some efficiency and effectivity in shipping industry. Thank you, sir.
Thank you very much. I trust Mumbai to D1, you have taken note of the support collaboration which you can do for further work on the fields which you are proposing, as well as the uh, expressions on slow steaming which have been expressed, and take that into account in your further work when you have any future concrete proposals to bring to the forum. Uh, if there is nothing further on the floor, uh, I would move on to then requesting Kochi even to take the floor and make their presentation.
Yes, sir. Good afternoon, Honorable Chairperson, Sir, Judge, and all the delegates from various member states present here in today's session. First of all, thank you, Chairperson, Sir, for providing the flow in IMO MEPC. We are the delegates of E1 MEPC Kochi. Our proposal is based on use of green ammonia to reduce GHG emission from the ship. Introduction. The ambition on GHG reduction targets have been set by government for the decades ahead in advancing our economies from fossil-based fuel to alternative energy. GHG emission from ship. 90% of everything we consume is moved by sea. As world is developing, volume and value of trade also grows. As world trade continues to grow, there is an increase in the number of ships crossing our oceans, each using vast amount of energy. The shipping industry is responsible for around 940 million tons of CO2 annually, which is at least 2.5% of the world's total CO2 emission. Then about the green ammonia. Ammonia turns out to be the best fuel that can be implemented considering the current status of technology and infrastructure in the world of shipping. The ability to use one fuel in all types of combustion engines and gas turbines, burners, and directly in fuel cells is a tremendous advantage. Ammonia is one of a very short list of fuels that can be used in nearly every type of engine and gas burners with only minor modifications. Storage and delivery infrastructure would be significantly reduced if ammonia is employed rather than hydrogen and other fuels. This is a table of the comparison, and this table gives the comprehensive study of the comparison of different alternative fuels. As result, you can see that ammonia has a higher energy density, about 12.7 mg per G, and it can be stored at a much less temperature, about minus 33 degrees Celsius, in which it's a great advantage rather than hydrogen, which has to be stored in about like minus 250.8 degrees Celsius. And it is cost effective compared to other carbon free fuels, and the transportation and storage is well established. Next is the production and storage. Ammonia is a key chemical produced in huge quantities worldwide. Its primary industrial production is by the Haber-Bosch method. Even though it's a traditional way of producing ammonia where it's not fully green and a small amount of CO2 will still be emitted. But the carbon capture technology can help to certain limit, but it's expensive and is not fully developed. Our interest is on the electrochemical cell through which we can produce ammonia with net zero emission. The electrochemical systems are grouped and described and discussed according to the operating temperature, which is determined by the electrolyte used in their performance and is evaluated. Coming to the proposal, we like to propose that to encourage the research and advanced development on direct ammonia fuel cell. The direct ammonia fuel cells are of SOC plus type with selected catalysts at the anode where gaseous ammonia is fed as a source of hydrogen, and to encourage the problems which need to be addressed further and order to scale up the electrochemical synthesis of ammonia to the industrial level are examined. Research for more better catalysts which would allow operation at low pressure and temperature. And also, countries like India, Australia are very much interested in producing the green ammonia. We have to further support and subsidize them. And ammonia is a very toxic, so as to eliminate any chance of leakage, we need to build an AI-based ammonia storage and supply monitoring system. For that, proper research and financial subsidies has to be given, and proper training should be given to handle the ammonia. Study has to be conducted for the safe usage of ammonia on board a ship, and proper amendments should be made in the IMO regulations regarding the usage of ammonia. And last, coming to the conclusion, at current rates, the greenhouse gas emissions, we have less than 8 years left in our global carbon budget. That gives two-thirds chance of staying under the critical threshold of 1.5 degrees Celsius of global warming. Ammonia seems to be a promising carbon-free energy carrier with high energy density and already available infrastructure distribution with respect to other carbon-free solutions. We request the committee to encourage the use of ammonia as fuel and to take the proper action, and also looking forward to collaborate with the different members of the state. Thank you.
Thank you very much, Kochi Evan, to bring about green ammonia as your proposal. Uh, it would be helpful if you could share what progress you have made in green ammonia usage in your member state, enable members benefit from that, and if that technology is made available to be able to take green ammonia further. So with that, we come to the summarizing of the session. I will leave Mumbai to C2 for the end of the summary. Meanwhile, we had
The intervention.
okay. Oh, so I'm getting tired. Sorry, sorry. C2 Mumbai Zone 2, please. The floor is yours.
Thank you, sir. We would like to congratulate Team Ivan on their extensive research. At the same time, we would also like to offer our support on scrubber technology that they have mentioned in their base paper. However, we would like to bring up some points about scrubbers. Scrubbers installation require extensive hot work to facilitate the extension of funnel area and attaching scrubber tower to the vessel structure. In this instant, I'm talking about a very specific incident that occurred in the near past. In this instant, data investigation revealed that crew had requested that the yard cover be opening, but this was not done. A fire risk to the scrubber patching during the hot work activity had not been identified by the yard personnel, and many of them were not aware of the internal components of scrubbers. So we would like to collaborate with Evan on this, on educating crew members as well as holding programs for educating like a very thorough education of scrubbers, the safety system, and rigorous safety standards can be maintained. Also, I would like to extend the support to green ammonia, that they also mentioned as an alternative fuel. We would also like to collaborate on the safety of green ammonia as the shipping industry has experienced ammonia as a fuel. Given the safety challenges and rigorous process of this assessment, fuel handling and propulsion system required. We would like to collaborate with them on setting up robust safety systems to move such incidents.
Thank you, C2, and I am sure Kochi Evan is looking and will collaborate with you on this. Uh, A2 Kochi, floor is yours.
Thank you, respected chairperson, for giving us the floor. We would like to appreciate the proposal that have been raised by the delegates of E1 membership. But we request the delegates of E1 to give more clarification. On page number 21 of their proposal paper under section 11.3, they have mentioned about the SCR technology to prevent the NOx emission. So how effective is this SCR technology, and what percentage this technology is able to control the NOx emission? Also, we would like to get clarification on what precautions and measures has to be taken by the personnel on board ship, considering the fact that ammonia is highly a toxic fuel. Thank you, sir.
Kochi Evan, you would like to respond? Kochi Evan, you're there?
Yes, sir.
Uh, do you have a response, or would you do some research and get back to A2?
Yes, sir. We would like to answer the question based on SSCR technology.
Please go ahead.
Okay, so basically, SSCR technology is used to reduce the NOx emission from ship exhaust. Actually, NOx emission exists for other alternative fuels, including hydrogen, when using retrofitting and internal combustion engines. But SSCR technology can be used up to an extent to reduce this, because I am saying that this is not a 100% 100% viable solution. In SSCR technology, the how it functions is that we just inject ammonia into the exhaust gas so that the NOx get converted to into an H2O. The catch is that here we need ammonia in SSCR technology, and since we are carrying the ammonia in the ship, this is a ship that is running on ammonia, so that it is easy for us to make the fuel supply infrastructure and everything. Since it is also it also prevents the it also prevent all other disadvantages that ammonia have, because we are designing ship basis on that. So uh, since ammonia is here for SCR technology and we are carrying ammonia, SCR technology is actually useful for exclusively useful for ammonia fuel ships.
Okay, thank you, Evan. I see the card of A2. Uh, A2, you have the floor.
Thank you, Chairperson. Uh, as the delegates of E1 member state, a developing member state have proposed green ammonia as an alternative fuel, and we also proposed it as a green hydrogen. So we would like to offer a collaboration because ammonia has three hydrogen atoms. So we would like to collaborate and offer fundings to them because we need a synergy among the member states and the recognized organization to achieve a net zero emission and to achieve a IMO resolutions. So, like earlier, they use maritime industry use sites and then they switch it to the coal and then they switch it to the fossil fuels. Now they are looking for a new alternative fuel. Maybe that may be the green hydrogen, the some compromise, and that will be the green ammonia. So, we like to offer collaborations and fundings to the developing member state even.
Sure, that will be great, and I'm sure Evan is taking note of it. And if we can assist in any way, please do let us know. Else, on a bilateral basis, you can proceed. I see no further cards on the table, so I'll try to summarize the session. Well, we had Kochi A2 and talk of green hide way forward in terms of an alternate fuel for maritime industry, while Kochi even felt green ammonia was the way forward, and possibly they will work amongst themselves to work out with concrete proposals, projects which can showcase to the world and help in further work. D1 did give us a lot of information about various options open and the need to explore the options to decide what is best. As their further research comes out, maybe they'll share concrete proposals in future. Now coming to the one paper which went into another area was declaration of a specific area as a controlled emission zone. Uh, there was also a reference that they had referred to recent in the last MEPC, the Mediterranean area was declared as a Sika area. I'm just going to share the paper and then share my views with the presenting member state.
I think you are a co-host. You have been made co-host.
I am seeing if I can do it. No, not so far.
I believe you have been made co-host.
Radish?
Radish, sir को allow sir.
This was submitted to MEPC 78 as MEPC 7811. You will note, number one, that it is agenda item 11. It is not reduction of greenhouse gases, and it is a specific agenda. So this was one thing which I wanted to share, not only for the benefit of the member state, but for other participants also. One has to be guided by the process and how agenda items are numbered. If you require a protection of a special area as a member state, uh, there is a specific agenda item under which you have to present that paper. And the next major thing which you require to see is this was Mediterranean Sea. Kindly have a look at the number of member states which proposed this. It was each and every member state which shares a common boundary with that water. This is to ensure that all interests are taken care of. Also, specifically, if you are bringing about a proposal on that, there is a specific guideline for putting up that proposal. I'll come to that section. The annexure deals with that, and in the annexure you have a section which gives you exactly what are the requirements to be fulfilled to be able to come to this conclusion that you can ask for a special area to be identified as a zone which emissions are controlled. Here, criteria for designation and emission control area. The following 8 criteria are laid out under section 3 of appendix 3 to MAPOL annex 6, that is running from 3.1.1 to 3.1.8. You require to be able to adhere to each of these criteria, prepare a study, and then you can come up with a proposal of this sort. So this was more in terms of education uh, rather than commenting on your paper.
Yes.
So you have brought about a relevant issue to the forum.
Yes, sir.
But just so that you remain aware that there is a methodology, that methodology, I am using this forum to sort of educate that would possibly have to be the way forward for taking such a proposal forward.
Chairperson, I would also like to bring this up. The 8 criteria that you presented, we did prepare some material on it, but we weren't sure if we could present it because the countries that are assigned to us are assigned as E1, D2, D2. So we can't know the geographical location, so we couldn't completely understand how we would be able to collaborate with other countries.
So
Because
in that case, like when you say East China Sea, you have already involved Japan.
yes, sir. But that
You have already involved a lot of things. So then either you should not have said East China Sea, you should have said our region or something.
coastal waters.
Yeah.
Okay, sir.
That would have been then keeping in line with your proposal. We appreciate these are issues, but I felt by sharing this I would be able to sort of give you more insight into that. I hope that has been helpful to you.
Yes. So, if it would be possible, we did come up with this idea. So, barring the teams that are selected, we would like to collaborate with some of the teams and just assume that they are in our geographical surroundings. So, would that be possible?
Yes, obviously.
Yes.
Like MEPC papers are submitted in people getting together and all. Why not?
Oh. Yes.
If you feel you could even have put a paragraph there that we are already in discussions with other these things who would at this moment, since they are not co-sponsors yet, but would support the paper on the floor of the house.
Okay, sir.
That would take care of it.
Okay, sir. Thank you, sir.
And of course, in an actual situation, you might have a scenario, let's take this particular case, that you are asking for this and there may be a island city for which fisheries is important and importer, they have got a long-term charter agreement for certain type of ships which cannot be retrofitted to do this and they may object to it. So those are, so this is what is understanding how regulations are built.
There is a particular passage in that paper also about route planning with the issue that you mentioned that ships could follow a different route that wouldn't get them into the ECA. Yes, sir. I would explore on that topic.
Good.
Yes, sir.
So thank you very much for your patience and your time participating in this, ladies and gentlemen. Mr. Ramamurthy would like to say something and I would hand over the floor to him. Ramamurthy sir. Sir, you are muted, sir. Sir, you are muted.
Yes, I just want to make a sort of information point of view. Now coming to this particularly sensitive sea areas, this has been there quite some time, and India tried very much to make Andaman area as a particularly sensitive sea area right from 2005. In fact, at that time there was an active committee we wanted to form with the Coast Guard, they were very, very interested, and the Andaman administration, as well as the ministry. Afterwards, many of the other areas in the world have become particularly sensitive sea areas. But it's more than now. So I wish some of them work on this, how to make all the 8 criterias, make it okay, working for Andaman Sea, and probably these students, or sorry, delegates, will do some work on that, and so that we get something for the country, because this is one of the very particularly sensitive sea areas. We have not got it. This happened actually. I think I have a feeling that the I think Galapagos, if I pronounce correctly, sea areas became particularly sensitive sea areas in 2005. We tried to have it ours much before that, but nothing succeeded. So now the future leaders, they should try to get this, because very important thing for our country to get this area, I mean, sort of getting as particularly sensitive sea areas. Previously, special areas were not included in that. It's only, I mean, ECAs and PSSAs used to be there. Now special areas are also included in this particular, totally. Thank you so much.
Right, sir. And I think I recently read that new cruise service has just started in Andamans about a week or 10 days back. So that is gaining a lot of prominence as uh, tourism also. So it will be of interest to make sure that the waters remain protected out there.
That's true. Yes, we should get something done on that.
Right. Anybody has any general comments? I open the floor for that before we conclude. I see no other observations. Then I declare the session closed. And thank you very much for joining us. Tomorrow we start the day with MSc, and look forward to seeing many of you there.
9 o'clock tomorrow.
Go over to you, Gaurav, for closing it. A small request to the judges: if everybody will log out, we'll just have a small discussion about tomorrow morning, and then we can also log off. Thank you.
Thank you, sir.
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 Thank you.
Thank you, sir.
Shall we log out? Shall we log
Thank you,
out?
sir.
I think we'll go.
No, Mr. Datta, you wait.
Yeah, I'm there. I'm there.
Okay, I think the session is closed. Tomorrow morning, 9 o'clock, sharp.
Yeah.
Okay.
Sir, can we log?
Please, please log out except judges and okay.
Yeah. Thank you, sir.
Thank you, Mr. Vakil.
The YouTube channel can be also switched off. Gaurav?
Radish? Radish, are you there? Please stop streaming in the YouTube. Okay. Okay. Stop recording also. Yeah. Sir, it's done.
There are some delegates still there. Can we
Please check the list of attendees and keep all microphone mute, otherwise cannot hear.
Gaurav, it might be better to start a new link.
yeah. Madam?
Yes, sir.
You cannot remove some people?
Dr. Yogana, can we have a new link? Is that possible?
Sir, tell me, sir. Sir, tell me once again.
Can we have a new link for the meeting? Because there are still some delegates on board who have not left. Maybe they have not available, so they could not sign off.
Yeah. One
Can
minute.
you send a link on email
Okay, sir.
or
Okay,
WhatsApp
only
or whatever?
I will create one new link, sir. I think it's only for judges and
Only
core
for
committee.
judges and core committee. That's
So I'm
Okay.
signing off. Bye. Signing off.
Okay.
we'll just email it to you, sir.
Yeah,
Then
yeah.
join that.
Okay.
At what time, sir? 5 o'clock or 5?
5 o'clock. 5 o'clock.
5 o'clock.
Okay.
By the time we can have a discussion.
Please send it on the WhatsApp also.
Right,
Okay, sir.
Thank you. Thank you. So we sign off from here, and then the judges we can come on the separate. I'll give a call.